Good morning. We're in the wrong presentation. That's probably a better one. It's probably going to be better. Yeah. You should, heck, I want to watch it. Does anybody else in the back see that we're projecting the wrong show? I mean, maybe we're in the wrong room.
We took over Nikolai's room, apparently. Sorry.
Are we just the overflow for Nikolai's room?
And you can just watch it. You have popcorn or something?
Yeah, I should. Oh, the traffic was a little special this morning.
Oh, my God. Who else was waiting for the tram? Oh, just me? How is that possible?
Who else was waiting for Uber? No,
Only
wait,
you.
Did you all walk?
Yay. That's what we should do tomorrow.
Is that fixed yet? Nope, still there.
Maybe we can get, a sound on at least so we can,
Yeah.
watch it.
Can we get that fixed? That's not us. Oh, okay.
I'm sorry, folks. These things happen, So.
Oh, my.
Yay.
Hooray! Okay, good. Yes. So, let's get started. Do you want to merge, or is there anything I need to add?
No. I think we merged. All fine.
Okay, this is yours. You can have that. Good stuff. Hi, everybody. My name is Josh, and
Good
this
morning.
is Alina Yurenko. I contracted the last and the first.
Thanks. We're all happy to see you here, and in this session we'll talk for 3 hours about Spring Boot, GraalVM, and all things AOT that you need to know to make your apps run with Spring Boot and GraalVM.
Yeah. How many of you using Spring? Curious? Just curious? Okay, good. The rest of you, get out of here. I'm just kidding. No.
But how many of you are using GraalVM?
Oh, okay. The rest of you stay.
You're in Spring. Maybe this will change after today.
Yeah.
Hopefully.
I saw the other day the people that of the people using GraalVM, the most of them are Spring users. Is that still true?
Oh, you looked at my community survey.
Yeah, great survey, right?
So there are many frameworks that work with GraalVM, but as Josh said, what you see at the moment is that most of the users who are using GraalVM indeed are using Spring Boot.
Right. So join the club. It's a fun place to be. It's nice. Look, we're in my core thesis this year, the thing I care about the most, the thing I'm most convinced of right now is that there's never, not even close, been a better time to be a Java developer. The platform has never been more compelling or more persuasive than it is right now. And one of the reasons is because of GraalVM. The other one, of course, Project Loom, about which we'll talk ever so briefly today as well. There's just a few things that just mean that your existing ecosystem, the entrenched sort of well-understood ecosystem of the last 28 plus odd years, now offers you new opportunities and new horizons, right? That knowledge, that investment you've made now takes you to new places that were just unthinkable, not even just like 5 years ago, right? So the fact that we can do that, the fact that we can just upgrade our code and benefit from that is huge. It's huge. So do you want to talk about what GraalVM is for a second? Or
I do want to talk about GraalVM. I do want to get online so that hopefully I can also show a demo.
It's DevOps Forever.
Yeah, I got it. I'm just checking if it's working.
So yeah, we'll transition to her laptop. Let me know when you need the HDMI.
Yeah, just 2 more minutes.
2 more minutes, no problem. So I'm a big fan of what we've been doing in the last few years. Spring Boot 3.0 came out last year, November 2022, right? And it was the first release to include an AOT engine, about which, of course, we'll talk at great length in this session. But it was not the first time we worked on it, right? We've been working on integrating Spring with GraalVM since, 2017, right? It's been one of those things, 2018 maybe. We had a Skunksworks sort of research project that we did in the background. And eventually, we unveiled that as a public experimental project called Spring Native. That came out, we started talking about it in late 2019, early 2020. I did my first Spring Tips video. I do YouTube. Oh, by the way, hey, you want to make not a terrible mistake? Like, there are mistakes you can make. Some of them are worse than others. This one's not the worst one. Go to here. Join me on the internet. It's going to be fine, okay? Good. So anyway, I did this video on the Spring Source Dev channel, the YouTube channel for the Spring team, looking at the very experimental, very new Spring Native project. And that project was Well, anyway, suffice it to say, things have come a long, long way since that very first build. That video, I did it on a Intel machine, Intel Mac, and it was using the state-of-the-art Spring Native support back then, which is super rough and looks nothing like what we have today. And I was using the state-of-the-art GraalVM back then, which looks nothing like what we have today. And that compilation for a tiny, sort of janky little app that almost barely didn't work, that compilation took more than 10 minutes, right? That was 2020. And by the way, I released that video in March of 2020. Famously, nothing else bad happened that month, right? The pandemic was terrible. It was terrible. But only because of the pandemic was that 10-minute compilation the second worst thing that happened to me that month, right? If it hadn't been for the pandemic, it would have been the worst. So yeah, like it was an interesting, but obviously not suitable thing at the time, right? I was looking at it, I was like, well, this has potential. This really does. This could be what we need, but it's just not there yet. And now here we are, 3 years odd years later, and I can't believe how compelling it is. Do you want to?
Amazing. That was a very nice build-up to my GraalVM.
GraalVM, woohoo!
Yeah, let me just get the cable.
Here we go.
Yeah,
we planned this.
Yes, this was all planned.
Oh. Come on, computer.
Okay, I was thinking for a second we'll see Nikolai again, but no, all good, it's my slides. Okay, so let's go into this. So Josh introduced briefly Spring Boot and GraalVM, and I want to give you a bit more context for GraalVM. I kind of hope that you know all the things that I will mention already, but just that we have the same base, can talk about the same things together, let's go through GraalVM. So GraalVM is a huge project, and there are so many things inside of it. In this session today, we will focus on native image and this ahead-of-time compilation of Java applications, but there is more. So one big part of GraalVM as a project is the JDK. So GraalVM is your normal JDK, just as you are using OpenJDK or whatever is the JDK distribution of your choice. And GraalVM is just the exact same JDK, only it has a brand new Graal compiler that replaces C2, the top-tier optimizing compiler in the JDK. And what is cool about GraalVM is that our own compiler, the Graal compiler, is itself written in Java. So normally things like that, compilers, virtual machines, are written in things like C++. What's wrong?
You took my power.
Oh, I mean, I think I can give it back to you.
Okay, yeah, you have to survive.
We are trying to share one cable, and as you can see, this is not exactly working out, but yeah, going good for now.
I'm running Slack. This battery does not have long. It's down to 78%.
I'm grateful that you said Slack and not didn't say that you will compile native image,
no,
so you need all the power in the world.
So, one Slack's worth of RAM. Anyway, carry on.
Yeah.
Sorry.
No problem. So we were talking about the GraalVM JDK and the GraalVM compiler and how it's itself written in Java. And you would think, okay, the compiler, but seems like something that should be very snappy and get to optimizing your code instantly. So how does it work for the GraalVM compiler itself being written in Java? Seems like it might need to warm up and all of that. Ask Josh.
So the just-in-time compiler, that's the original use case, right? And I remember our friends over at Twitter talked about their use of that. And even that was persuasive just by itself.
Oh, Chris Tallinger. Can we give Chris some proper credit?
Of course,
Anyone here have ever been to Chris Tallinger's talk when he talked about Twitter and how they're using Graal there? Yes.
Amazing. Like 10% or whatever improvements
I mean, it was Scala, so I feel like it was maybe like 20% or something. But, you know, if you ever use Twitter, you kind of ran on GraalVM because that was they used as a JDK, right?
So it wasn't native image. It was just a better just-in-time compiler. And I don't know. I heard the original just-in-time compiler that you get out of the box is like a plate of spaghetti C++ code, right? Whereas the new one was all Java and very clean and much more sort of capable.
That is true. So we kind of work with Java every day ourselves, you know, because our compiler is written in Java. But one more cool thing which I love about it, it's written in Java, right, itself. So it's a Java program technically. So what we did to avoid that possible startup and warm-up curve is that we compiled the compiler with native image because we can. So in the end, it's compiled to native image, like you would compile your own application, and that is how we ship it within the JDK. So we are kind of reusing our own technology, and we will not go into many details about this now, but all those parts of the GraalVM project and ecosystem, they kind of amplify each other, because we have the compiler, we have native image, and here we have native image compiling this compiler, so that you have native compiler in the end. How cool is that?
turtles all the way down. And then you've got the other stuff.
We got way more stuff.
Yeah.
So again, we will not go into those today here, but we also have Truffle, which is our language implementation framework. So if you ever heard of things like GraalJS, Graal Python, Truffle Ruby, which is our Ruby implementation, all of that is implemented on GraalVM. So if you have your little maybe dream to implement your own language, so maybe you have an idea for a language, or you think you can come up with a better implementation than existing ones, you can implement a language on GraalVM fairly easily. What you will need to do, you will write an interpreter for your language in Java, and then GraalVM will give you tooling, and it will also optimize this interpreter together with your workload to give you a high-performance implementation of your language. And as an example of that, we saw this very cool example on Twitter where a student, as a part of their master thesis or something, implemented PHP, Josh's favorite all-time language, so implemented PHP in his free time on GraalVM in something like 6 months. So if you ever wanted to have your own language implementation, Truffle and GraalVM is the way to go. Josh, maybe PHP on Graal, that could be your next pet project.
Pass.
Too bad, but could be fun.
Yeah, or not. So we have GraalVM. GraalVM is this like amazing project. And by the way, the Truffle thing I think is, it's like the .NET CLR. It could be, you know, the sort of solid foundational pieces that the ecosystem needs to build a bunch of languages. There's like you just mentioned like 5 or 6 languages.
Oh, there is a million languages. Let me show you that because there are some very cool ones which I love. Okay, let me see if I can quickly
You can use R, right? Like
Truffle languages. Okay, look at this. So the first one here on top, that's more or less official language implementations from our team. And then below, there are experiments of exactly of people who implemented things on GraalVM and Truffle. And look, there are some cool languages here, like Lua Truffle. How cool is that? Yeah. And my favorite, I think we have 2 implementations of BrainFuck on Truffle. So that's even better, I feel like.
Yeah, just an amazing thing. And that also, in theory, if the implementation is done in the right way, those things can in turn use native images. Is that the idea?
Yeah,
theoretically.
Two things. I mean, I feel like we are taking this too far and like pushing what people can follow. But just I think I can say this quickly. So one cool thing is that like since all the languages are implemented in the same way, they can communicate with each other easily. So you can call, let's say, Python from Java if you want to use some cool ML library. You can embed it in Java and you can use it directly from Java. That is that, but also what Josh said, that you can have a native application, so your Java natively compiled application, that also can use this Python, JavaScript, whatever. So if you have Java app that is calling into those polyglot languages, you can still compile it to native, only the Java parts will be compiled ahead of time, and those JavaScript, Python, etc. will be dynamically executed. But it is possible to build a native executable with all those languages included.
Nice. Okay.
Native image. Should we talk about it?
Right. I think that's why we're all here. But I just want to so first of all, GraalVM is
amazing.
Open source.
Yes, it's open source, and you can yourself go and check it out. It's here on GitHub. So we can see that it's indeed open source, and also here we can see that, you know, look at the language distribution. So most of it is written in Java, just like we told you. And somebody told me, I don't know how to verify that, maybe you have ideas, but somebody told me that it might be one of the biggest open source Java projects out there, because it's indeed huge, right? So it's the compiler, it's Truffle, it's language implementations, it's indeed a huge, big Java open source project.
And it's built on OpenJDK though, right?
Yes.
So it's a bunch of things in addition to so it's OpenJDK++. So the question then obviously is, if you're shipping GraalVM as part of a Java 21 distribution, are you able to use Java 21?
Absolutely. I'm glad you asked. Just when was it last week? 2 weeks ago, that we released Java 21, and on the same day we also released GraalVM for JDK 21. So that's really great because you can use all the latest features from JDK 21 together with GraalVM and our latest features. No, it's all working, and even your maybe favorite thing, virtual threads.
Oh yeah.
And now GA on GraalVM, including native image. So you could have used those before with the enable preview flag. But this is not mandatory anymore. It just works out of the box, and hopefully you will see it a bit in the presentation as well.
Yeah, I appreciate that. No, I meant, does the GraalVM team get to use Java 21?
Sure.
When they build GraalVM
we do use Java 21, let's put it that way.
Within, okay, cool. Yeah, like, anyway, just an amazing project, all open source, Apache, I don't know what the license is, GPL?
No, GPL.
GPL, and there's another distribution.
There is another distribution, right. So we have an open source edition, GraalVM Community Edition, and we have a commercial one, which is called Oracle GraalVM. And functionally, I would say they are equal, so you can do native image, truffle, etc. with each of those. But Oracle GraalVM gives you some additional performance optimizations on top, and we will actually get to this in a second. I do want to talk about performance. This is my favorite topic. So there's AOT versus JIT. So we all know and love JVM because it gives us this amazing performance and runtime, right? We all use Java for peak performance, I mean, for the libraries, ecosystem, you know, all of that, but also we are really used to this amazing peak performance. And when we talk about native image and ahead-of-time compilation of Java, sometimes people have this question, but, you know, AOT code, AOT compiled code will now be as fast as JIT because, you know, JIT is executed dynamically at runtime, you have profile information, you can adapt on the go, you can see what exactly the application does. So how can AOT, you know, working ahead of time under closed world assumption, how can it be as fast as JIT? So do you think if we compile our code ahead of time, can it be as fast as JIT at least? So at least on par, can it be or not? Okay, a few optimistic people, but overall rather skeptical. So recently I was talking to students at university, and they had an opposite kind of sentiment. They think that AOT compiled code will be faster than JIT. So it's a very interesting, you know, bias that we have in different communities. But indeed, JVM can give us this great peak performance. What's interesting, though, with GraalVM and native image, we can get the same, if not better, peak performance as you get on JIT. Okay, let me see, hopefully, that my internet connection is still on. No, it's fine.
No, it's not. I didn't realize you were so low. Okay. Oh, my God.
Okay, let's see if I can demonstrate it. And I have a lot of faith in the conference Wi-Fi, so I hope this works. So what we have here is my little...
Stop torrenting.
Please, like for 5 minutes. You can get back to it later, but just 5 minutes, I need my bandwidth, and then you can go back to it. So I have my little Spring application that just exposes an endpoint, and I already have it compiled to a native image. And let's see first how it runs. Let me just close this, and let me get back here and clear this. Okay, it runs. In started, it's something like 1 second. I mean, okay, but we will see if we can improve it. And then let's go to my local host, and here is my message. So, you know, not very exciting, but, you know, it will get more exciting. Let's get there. So this was my JIT application.
I love that you have an emoji.
Of course I have an emoji. Everything is better with emojis.
Yeah, and by the way, new feature in Java 21, so you don't feel like you're missing out on Nikolai's talk. New feature in Java 21, there's a way to detect emojis now. You can actually do character.isEmoji. So, you know, don't say you didn't learn anything.
Very useful. If you're a cool kid like me and you love your emojis and you need your emojis, now it got just better.
Yep. There you go.
Okay, let's see what else we have here. So in my target, I have a number of compiled applications. I will only use 2 of them, but what we have here is, for example, my demo app. That's a very basic one, and we can see that this is indeed a native executable. So let's go ahead and run this one. Oh, and I realized that you don't have a screen, so you don't even see what I'm doing. I'm sorry. Let me just move this. Let's be nice, and let's also include Josh in like what's going on. Okay. Okay, it started, but let's see that it indeed runs. Let me just close this and reopen it, so there is nothing sketchy going on. The same message. We got our emoji. All good. But now if you pay attention, it started in what? 0.33 seconds. How cool is that? Okay, that doesn't take my word for it. Okay, he needs to double check what's going on there.
Oh, you don't have the... Wait, okay, can I do something?
Oh my God, what are you doing to my machine?
When I just... Wait, how did... Oh, it's the...
Okay, this is totally unplanned.
Is this a Xerti? No, it's... Okay, so it's a access...
Oh, you want to do the zooming in thing?
Don't you?
No, you
Everybody
can
wants
just
to zoom in.
plus.
So here, zoom. Okay, use scroll gestures. So la la la. Ta-da! Okay.
Beautiful. I also learned something new today, and it's only been like 20 minutes.
Where's
Amazing.
the console?
Oh, let me get.
Oh no! Where'd it go? Where's the output?
Here.
Oh, okay, I didn't know. I'm new at this. Okay, so.
New at this stuff.
Yeah. Dun 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 dun.
Ta-da!
Yeah.
I mean, you're not zoom. Okay. We are zooming in the right place. Amazing.
Yeah, there you go. So
how did you do it?
Control and then swipe up and down.
control.
And then two fingers swipe up and down.
Yeah, no.
Just hold down two fingers and go up and down. Like.
Oh.
Yeah.
Oh my God. Okay, this
So
will take a while for me
much
to get
power.
used to it. Amazing. Okay, we all learned something here, hopefully. But you know, startup is one thing, but some people would argue that startup is not the most important thing.
That's
and I
me.
agree. Okay, good to know.
I would argue that.
And I agree that startup is not always the most important thing. So it could be that you are running long-running applications and you care less about startup, but you might be caring about other things. So one of the things you might be caring about is, for example, resources usage. So if you're deploying your applications to the cloud and there you're paying for the resources, such as maybe less CPU, but you're more concerned about memory usage, if you can have the same application, but run it using less memory, it will be very helpful because then you can reduce your cloud costs. Or if you, let's say, running on your local infrastructure, you can deploy more of such applications, but have the exact same work being done for you. And that is happening because native image, unlike the JVM, doesn't execute code dynamically at runtime anymore, so it doesn't need to bring all that code execution infrastructure to runtime. We compile everything ahead of time, and then in the end, when you're running the app like we did right now, what you have is completely optimized and compiled ahead of time application that doesn't need all that code execution, compilation, etc. happening at runtime. So this way, it also reduces the amount of memory we are using significantly. But I came here to show you peak performance. So let's get to peak performance, and maybe if we can remember to show memory later on in the talk, that would be amazing.
Okay, I can do that.
Okay, peak performance. So do you think I can make this app as fast as the JIT version?
I'm going to say yes, because I have learned not
Because
to...
I'm with you here on the stage, so otherwise that will be
I
embarrassing.
have learned not to bet against you.
Oh, you also learned something today. Look at
Yeah,
that.
exactly.
Amazing. Okay. So we have a bunch of versions of this application, as I showed you before. Where was it? Okay. So let's do some quick and dirty benchmarking. So this will not be, very sanitized, very clean way to do benchmarking, but this will be good enough to have some basic conclusions about AOT versus JIT performance. So let me run my app again on the JVM. Where was it? This one. Okay, it's starting, and let me just check that it's on. Yeah, it's on, all good. And here we will use a tool called Hey to send some load to our application and see how it works. So I will send, let's say, what is this, 100K requests to our endpoint and see how it works. And this right now, this is running at the moment on the JVM. So let's do this. And I like Hey because it gives you a very nice, let me just make this bigger, it gives you a very nice kind of visual output of various performance metrics. So if you like latency, maybe you have some kind of SLA to meet, you can look at latency. But for me, what I like looking at the most is peak performance, just because it's, cooler. And for me, what is going on with the sound? Am I doing something? Okay, good. Moving on, latency. So we can look at latency, and we see that most of our requests are below 4 milliseconds here. But I'm curious about peak throughput. So peak throughput here is, where is my peak throughput? This is the last output, 52K requests per second. I mean, kind of looks good to me, but maybe it is good, maybe it's not. We wouldn't know unless we compare against something. So let's compare this to JIT. Sorry.
Yeah?
Did my sound disappear?
Oh, it's back.
Am I banned? Like, am I talking too much?
It's back. Okay, good.
Okay, let's do the JIT stuff. And let me just go back to English and not Ukrainian. Okay, good. So let's run our native app. And this is a plain native app, no magic happening yet, but it is running on Oracle GraalVM, so the commercial edition of GraalVM, but without any boosters yet, so just as you would compile it kind of out of the box. So this is now on in the native mode, plain native image, and let's hit it with the same workload. So just to memorize, this was 52K for JIT, and now we are at 70K for native image. Wow. Obviously, I like that you're impressed. Can we give native image some credit for beating JIT? Because JIT is an amazing piece of engineering. It's not very easy to beat it. Now, here you can say that this is just one workload, one endpoint, and I agree with you that it depends heavily on what your application does, exactly the operation it performs, dependencies, etc. So your numbers might vary, and if I'm asked, how much performance I can expect from GraalVM native image, it's very hard to give a generic number because there is no generic workload. But what I'm showing here is that you can achieve on par or better performance with native image as you would on the JVM. But we can do even better than that. So let's look at my app. And where was my POM XML? So I have a number of profiles here because I was experimenting with some things. But the one that I'm interested in is this one. So this is you can also go back and I can make a point here that when you're building Spring applications, it will show you creating one from scratch. But the number thing you want to do is have the Spring Boot Maven plugin. And you also want to have a native Maven plugin coming from GraalVM's native build tools. So those two things will give you a lot of tools and necessary information to build your applications for GraalVM native image. Now, going back to my cool profile and what is happening here, where is it fully optimized? This one. So here I was trying to see if I can optimize the performance of my application even further. So as you see, we were already beating JIT for this particular workload, but there are more things that we can do. And what is happening here, let me go through. So one thing is you can see that I'm passing this PGO flag here, and I'm picking up my profile information from my project. So this is probably the most helpful thing if you want to achieve good peak performance, and this is profile-guided optimizations. So what this thing does, see, like Josh already admires it. I agree because this is super cool. So as we talked right on JIT, one of the reasons why you get such a good peak performance is because you have profile information available at you at runtime about what exactly is happening in your application, which methods and loops are hot, and so on. And native image, it compiles the application ahead of time at the build step. So technically, there is no way of knowing what will happen at runtime and which parts of the application will become hot. So by default, it's hard to optimize for peak performance because you just don't know what will happen at runtime. But there is a way to approach this, and this is exactly PGO. So with this, what you can do is that you can build an instrumented binary of your application, run it, apply relevant workloads, and let GraalVM collect profile information of your application. Then you can then feed to the native image builder when you are building your application. And this way, you can build a native executable that is kind of aware of runtime and what will happen at runtime. And this is, I think, super cool, because this way you are combining the best of both worlds. So you still have fast startup, low memory usage, etc. from native image, but you are combining this with the power of dynamic code execution because you suddenly become aware of the runtime information of your application. How cool is that?
Sorcery. Witchcraft. I love it. I love
it
it
is
so much.
Sorcery. And just two more flags. I will go through those briefly, and then we can transition to Spring 101.
Sure.
So two more flags that could be useful for you in terms of peak performance. So MARC native, this is a rather new one. I think we introduced this 2 releases ago. So this will help me utilize better CPU-specific features of my machine. So with this MARC flag, you can choose between compatibility or optimizing for the best peak performance. And the way you would approach this is that since I'm building my executable on the machine where I will be actually running it, it makes sense for me to optimize my workload for this specific machine, because this is where I will be running my application. Now, if you will be distributing your application and you don't know what kind of machines and CPUs will be there, you might want to skip this flag. But since I will be running this app on my machine, it makes sense for me to make the best use of my machine. And one more flag here is the Juvan GC. So again, if I want to have a bit better performance on native image, I have a bunch of options. By default, you get serial GC. But again, if you want to optimize for better performance, especially for slightly longer running or maybe slightly bigger applications, Juvan is your way to go.
So this is profile-guided optimization, right?
Yes.
PGO. That's in the Oracle
GraalVM.
That costs money. And
let me stop you there. Technically, it doesn't, because there is now a new free license. Did you know that?
There's a free tier license?
There is a free license.
So I can use it?
You can use it.
Because they just pay me in coffee. I don't actually get paid. So I would like to use that, please. No, but remember, the nice people at Oracle are doing a lot to build JDKs for us. It seems like they should get some money. That'd be fine. That'd be a good deal. So
yeah, but since you touched the topic super briefly, indeed there is a new free license. So it's called GFTC license, which is kind of similar if you ever faced Oracle's Oracle JDK and FTC license. So you can use this commercial edition in production for free. That is it. Yep, and you get all those features.
Oh, wow.
So long story short, let me run also this app and see if this gets any better. So I have a version of this application compiled with all those optimizations, and where was it? I think it's called fully optimized. Yeah, that's the one. So let me run this one, and let me kill the previous one. Demo optimized. It's on, and let's navigate it with the load. OK, done. And if you remember, on the JIT, we were getting something like 51K per second. Now, on plain native image, we were getting 70K operations per second. And here we have 79 operations per second. So out of the box, you will get good performance. But also, if you want to get a bit extra, I mean, each workload is different, so you need to try and see what works best for you. But this combination of flags probably will be helpful for you. Now, and I want to show one more cool chart. It's a bit like, it will take a second to parse, but I'm there with you. So one more thing that we did for the last release, we published some performance numbers for Spring Pad Cleaning. Josh, do you like Spring Pad Cleaning?
I've heard of it, yeah.
Yep, amazing. you must have.
Yep.
So there is this beautiful chart, which, as I said, will take a second to parse, but like we will do this together. So what we are looking here at is performance numbers for this Spring Pad Cleaning application. And what we are measuring is operations per gigabyte second, so how much throughput we are getting for our resources in the given time frame. And we are mapping this against our XMX settings to see if I change my XMX settings for my pad cleaning application, how does that affect performance that I'm getting for my resources. OK, so this is not like easy to parse, but hopefully you know it got a bit clearer now. And what we see here is two things. So the orange one, that is native image, so ahead of time compiled code. And the blue line, that is GraalVM CE with C2 JIT. So C2 is a default OpenJDK compiler. So what you see in the blue, it's basically your OpenJDK kind of setup. And two things that I see here is that, like, OK, the line itself, it shows you throughput per memory, basically, right, per time. So overall, native image gives you better throughput per memory than JIT, just because it gives you good performance but uses way less resources. And one more observation here that I find interesting is that you can see how there is this kind of peak difference between them, I would say around maybe 12 megabyte heap, right? So for applications with small to, I would say, medium heaps, so up and around 1 gig, for a native image, you can get almost twice as much throughput per memory as you would with JIT, because performance, as you've seen, was good, but you are saving memory. So for the amount of resources that you have, you can get way more performance with native image. OK, and I feel like I've talked a lot, and Josh has been unusually quiet, so I feel like I should hand this to him, and we should talk about the Sprint 101.
OK, that's amazing. All that is a very, very, very difficult act to follow. But I feel like we've made the case for GraalVM, and I just kind of want to like talk about the state of the art, because one of the things that I just noticed when we saw that amazing demo, that performance didn't even. You plug in. I'm so sorry. I'm so sorry.
Look how nice he is.
No.
Oh my God.
I didn't realize
morning.
She's got like 5% power. I thought I was looking at a different bar. I thought it was like I thought she had a different bar. I didn't realize I was looking at the wrong thing. She's got no power. So I've got 85. That'll last me. I need it
until
back
tomorrow.
I'll need it back before
you can
tomorrow
get one
evening.
more talk with that.
Yeah. I need it back before the BOF tomorrow evening for the spring BOF, because I'll probably be out of power by then. What you didn't talk about, completely reasonably, is like, because we're talking about throughput, right? Project Loom. This is a new thing in Java 21. There's just so many other things you could do to make that thing go even faster across the board. And so what I wanted to do is just to briefly talk about the state of the art in Spring. We'll see that all that stuff works just as you'd expect in the happy path with GraalVM. And then we'll go back to basics and talk about what happens and what do you do when things don't work out of the box, okay? So we're going to just quickly take a brief tour of Springdom, okay? And my goal here is just to throw a lot at you and then just watch it all go to
for 3 hours.
Well, we're going to, whatever, 20 minutes or something like that. Okay, so we're going to build a brand new application as usual. Start.spring today. We're going to build a new application. I'm going to be using Java 21. Gradle and Java 21 are not friends at the moment, right? Gradle, I think you can use the early access for the 8X series.
And you can do tool chains, right?
Yeah, anyway, the experience is just a bit more consistently okay on Maven. Java 21 just came out. Well, it didn't just came out. It's almost 2 weeks old. It's achingly old. So I fully expect that all of you have it installed already, right? Is that true? Raise your show of hands. Who's already using it in production? Good. Oh, hey, that. I tricked you. I asked 2 questions. Who's using it, and then who's using it in production? And they're like, oh, I'm using it. No, not in production, not yet. Okay, so you should definitely be using it in production. So SDK list Java, okay? And so I'm using sdkman.io, which is a Fabu way to install stuff. And I've just, I want the best of both worlds. I want Java 21 and GraalVM. So I'm using the community edition. Really, I should be using the free Oracle one. 21 Graal CE, so you just do SDK, install Java, that, okay? And then much better, once you've done that, very quickly, do not forget this. In fact, you should chain them together, make it your default, okay? For all shells. There you go. Now you're in a good place. You'll never have sadness in your life, okay? So we're going to build a new application. I'm also going to use the brand new 3.20 M3 milestones. And then we're going to build an app, okay? I'm going to call this, whatever, I don't care, just app service. I'll call it service. And then we're going to use Java 21, right? Java 21 right there. Uh-oh, what's wrong? Oh, thank you.
See your machine.
Oh, sorry. Let me put that on here. There. So, okay, we're going to just, and, we're going to use, how many of you are using Spring Boot 3.x yet? Okay, good.
Was that in the room? Oh, my God.
That's great. 3.1. Smaller. And who's tried out the 3.2 bits? Okay, well that's not great. Okay, we're just gonna go through it very quickly. This is I'm happy to report a lot of this will be rehashed for most of you. So GraalVM, dev tools, test containers, Postgres, data, JDBC, web. Okay, good. We got that simple kind of thing going on here. Application. Do I need anything else? GraalVM, dev tools, test containers, Postgres. Okay, hit generate. I'm gonna open this up. Here we are. Oh, it's okay. I've got it here. Okay, let's see. So, service application. Come on, do the thing. Wake up. There we go. Good. Public static void main. So we're going to build an application. I want to talk to an application that's got it's going to have a database. I want that git clone run life. So of course, a big feature here, so you don't feel like you're missing out on the test containers workshop, is we're using test containers, right? This is a Java API for running Docker images, and we've got this public static void main class in the test folder here. So it's public static void main, but it's got extra configuration. It's just a configuration class. When you run this configuration and this public static void main, it adds this one extra bean. This is great for development. I'm going to use this Docker image. But I also am using dev tools. And the idea behind dev tools is that as fast as Java is, it's not particularly fast when doing restarts. And I like to make changes and see them reloaded very quickly. So I'm going to run this, but I'm going to also annotate this with restart scope. And the reason is because Java, the dev tools, does a live reload of your bean factory, of your application context, throwing away the classes whenever it sees a new change. This is very fast, except when you have something very slow in your bean context, like, for example, when you start a new Docker image, right? If you restart your Java application as written right now, then this will recreate Postgres every single time, and I don't want that. I want to tell it to just exclude this one bean from the recreation of the bean factory, and that's called restart scope. So we're going to go ahead and add that there. Run this. Okay, come on, public, come on, you got this. Neat, okay? So this takes an achingly long time because remember, it's downloading a Docker image, right? It's downloading a Docker image for me on the very first time. It's also creating a connection to this database. It's got this service connection annotation. It understands that this is a SQL database, and therefore I probably want that plugged in for the values for spring.datasource.url, spring.datasource.username, etc. I don't have to plug that in myself. It'll automatically sort of determine that stuff by looking at this annotation. Okay, so it takes a long time. It took an achingly long 3.2 seconds to start up the Postgres instance and to start up the application. Okay, so we've got the application. Now I can start writing. I can start making changes. I'm going to use this integer ID string name. I'm going to create an entity here. It's got an @ID annotation. I'm going to use. By the way, how many of you are using records? Okay, records are great. Did you know that records are actually part of a larger sort of thing around data-oriented programming now? Have you seen some of this, data-oriented programming? Okay, let's just briefly take a little digression here just to kind of cover the state of the art here. So void, I don't know, there we go, okay? So imagine there's actually 3 features now. There's sealed classes, there's records, and there are pattern matching, right? And so all 3 of these things taken together give you, I guess, what they're calling data-oriented programming. And so the sealed classes, let's say I have a interface loan, okay, and you know, whatever, float rate or something like that, right? And I've got sealed implementations of that. So I'm going to say sealed interface loan. And the reason I'm sealing it is because I'm telling the compiler, look, loans are very, very complex things. I have lots of places where I calculate things in my code base. I want to make sure that I've covered all possible permutations of this hierarchy, right? So I have to give a permits, and so okay, say class secured loan, implement loan, and then unsecured. Okay, so I've got 2 different kinds of loans. I'm going to permit those loans, secured loan and unsecured loan, right? Very, very important that I cover both of these things. And because because I'm trying to seal, I'm trying to hermetically seal the hierarchy, these need to either be sealed and then permit subclasses, or they need to be final, okay? So, and then we have the, let's see, the default, let's see, whatever, we can have a default rate return 0.0, and then for the unsecured loan, you know, rate equals 1.0, whatever, okay? So 1.0, okay? So now we've got these 2 different hierarchies. There we go, 2 different types. I want to deal with these. And this is just a sealed hierarchy, not so interesting by itself, but where this comes into play, of course, is, well, first of all, this loan, if you think about it, I could actually make these records, first of all, but we'll talk about that in a second. And second of all, I can use them in pattern matching. So let's say I wanted to create like a you know, rate, you know, amount due every month, and I wanted to look at each instance in that. So I've got now a instance of loan equals new unsecured loan, right? And I'm going to deal with each one of those. I'm going to look at the unsecured loan. I'll say switch over the loan. Imagine I've got a method there, and I'm going to switch over the loans, and I want to make sure I've handled the calculations on the loan each time, right? So does not have any case clauses. Yeah, I get it. Case. So now we can use pattern matching. We can say, okay, if it's an unsecured loan, then the, you know, there you go. Then the rate, you know, the rate will be unsecured loan times rate times whatever, 0.05. Okay, or actually no, integer dot max value minus 10, right? Whatever, some crazy number. It's very, very high, very expensive these days. Interest is through the roof, okay? So 0.05 f. And then if you have another loan, well, I have to handle that case, don't I? Right? I've got a secured loan and I have an unsecured loan. One does wonder why the compiler hasn't. Oh, loan. We don't know what kind of loan it is. There, casting that down. Now the compiler is saying, hey, you haven't covered all possible input values, right? So if it's now a secured loan, right, I need to handle the secured loan situation there, and I'll just say 0.01 f, okay? So now the compiler is watching out for us, is making sure that we've covered all those different cases. The ability to say this is a type, and I'm switching on the type itself, that's called pattern matching. And I'm using this enhanced switch expression here. This is not, there's no break here, there's no default. I'm just using expression, so I'm able to assign the results of the switch to the value there. So now that's pretty cool, right? In of itself, that's kind of cool. Going a step further, let's suppose that I have a loan, but now I want these to be records. So I'll say record float rate, okay? So now I've got a record, and then I go here and I say record float rate implements a loan, and I don't need this anymore, okay? So now the components are part of it. And maybe with the unsecured, maybe with the secured loan, it's just, you know, 0, but we can assume it's 0. But for the unsecured loan, I have a variable amount, okay? So in this case, maybe I don't want to deal with the unsecured loan and dereference the value there. So unsecured loan is whatever, 5.0, okay? So maybe I don't want to do that. Maybe I can extract out the rate. So I say float rate, right? And now I can use pattern matching to hoist the value of that component value into its own variable here, right? And then this, of course, doesn't have it anymore, so it's just 0.01, whatever, okay? So this is another thing that's kind of nice, is pattern matching. I'm able to extract out the constituent component parts of the record into their own variable and then use that in the calculations. And then what's wrong with this? Oh, there's no, okay, there you go. So this is these things, data-oriented programming, the idea that I'm now dealing with objects, ad hoc small objects in my code base, and that's the boundary along which I do dispatch, not my deeply rooted hierarchies of interfaces and so on, as we used to see before. That's really interesting. That's a new thing that's enabled in Java 21. So when you see me cavalierly just create a record like this, just remember that unlocks a whole other sphere of new features. Okay, so there's this. Now I've got interface customer repository. Okay, extends list of CRUD repository, managing customers, integer primary key. Good. And then I'm going to create a customer HTTP controller, and I'll inject the customer repository. Okay, add this, and we'll say at get mapping customers. Okay, whoop. Return this dot repository at find all, and at controller at response body. Very good. So there's our basic simple HTTP entity. I need some data in the database, so I'm going to go back to source main resources. I'm going to create two files. I'll create a file here called schema.sql. I'll say create table if non-exist customers ID serial primary key name var car 255 not null not noi. Okay, there we go.
I'm going to French again.
Yeah. So there's this, and I'm going to go to data.sql, and I'll say okay, delete from customer, and we'll just insert some people who are speaking today. Insert into customer name. What the? Name, values, okay.
Thanks.
And I can't even spell my own name. It's not going to go well. Okay, so there's this. I'm going to now make sure that Spring Boot automatically initializes the application, because remember, from the perspective of the Spring Boot application, even though we're using Docker from within the Java process to launch the Postgres, this is still not an embedded database in the way that Derby or HSQL or whatever are embedded databases. So I'm going to tell Spring Boot to run the SQL initialization against the just run Postgres instance. Okay, so all that to say, I now have a data application that has an HTTP controller, a repository, an entity. I've got my SQL. I'm using test containers to do the git clone run. I'm going to now do Command Shift F9. That's a recompile. So I go here. I'm not rebuilding. I'm just recompiling the application, right? Command Shift F9 there to recompile the application. And if I go to the command line here on the console, you can see that it restarted that in 0.28 seconds, which is great, right? Now I don't have to wait for the Docker image to spin up. So I go localhost customers, voila, there we go. It worked. Of course, it worked. It was a demo. Now, so we have our basic application. This is all pretty stock standard stuff, obviously, but we have not stood still. So on the Spring team, for example, so desktop talk AI.md, there's all sorts of new stuff that you can do now, right? And so let's go down here and let's just add some dependencies. First of all, I'm going to add a repository here. I'll go down to the repositories, ID, snapshot, URL, and voila, there's this. Okay, and then we go back up here, and we're going to add a dependency, which is this right here. So I'll say dependency, org Spring Framework, AI, group ID, and Spring AI, Spring AI, OpenAI, Spring Boot Starter, blah. It's a mouthful. Okay, version, add this, good. Okay, so I've got the dependencies in the application, on the class path. I'll restart it, because that's a class path change. I have to restart now, a full-on restart. Okay, and the benefit of that is I can now use it to ask questions. I can say, okay, story controller, and I'll use the AI client. Okay, AIC. Okay, and we'll create an endpoint story map of string story time, right? And we'll say return map.of story. We'll say equals this.aic.generate, and let's see here. Okay, good. Tell me a story about the amazing food in Belgium and do it in the style of famed children's author Dr. Seuss.
Oh my God, this can go so wrong.
All right.
I can see it.
All right. It's gonna be fine. So I'll say generate that, and I'll say give me this story. And remember, like I'm using multi-line strings, yay, future, and I've got I've got this AI plugged in, good stuff. Okay, there we go. So
it's like a bleeding edge talk. Look at that. GraalVM,
yeah.
Spring Boot, JDK 21, AI, like everything in one talk.
Yeah. Okay. So we go now here and we say story, and now we have to wait, right? I don't know what this is. What is? I'm trying to use Safari this year, but
what are those?
I don't know what it's trying to tell me. What is this?
Oh, coffee. I can get behind
that.
Yeah,
but why is it offering it when I see a blank page full of
Why is Safari? Oh my God.
Yeah. Okay. Once in a land called Belgium, oh my, there lived a chef who could cook, oh so high. His name was Chef Pierre, quite the culinary whiz, with a mustache so grand and a talent that's his. In a quaint little town where the waffles were sweet, Chef Pierre cooked dishes that couldn't be beat. He'd start with some mussels, plump and so fine, steamed in beer with garlic divine. Then there were fries, oh so crispy and light, cooked twice in oil. They were out of sight, served with mayonnaise, a Belgian delight. They vanished so quickly, bite after bite. You get the idea. They can do story time. Okay, so anyway, that's where we are. We've got an application that's talking to the database, and we've got another one that's talking to the singularity and giving us a quick nursery rhyme. Okay, and the reason that's interesting is because look how long it took for me to get that. Right, I refreshed, and we're just waiting and waiting and waiting and waiting and waiting.
Oh, cool.
I'll just wait for some. I'll have some water here. So the reason that's a problem is because think about what's happening when we make that request, right? When I make this request here, I say singularity, singularity. I say singularity.generate, and then I make the request. And if I look at this, I'm right here on line 52. I'm on one thread, and when I get over here, I'm on another. I'm still on the same thread, right? And that's a problem because I'm wasting that thread. Okay, and so this forecloses upon scalability, right? Obviously, I don't want to waste threads, especially in Java's prior to Java 21. Threads are expensive. They take about 2 megabytes of heap for each new thread, right? They correspond one-to-one to operating system threads. This means that if you are going to do something, trying to handle a web request, the last thing you want to do is to sit there just wasting time waiting for something to happen on that thread because you've got so precious few of them. They are a bottleneck to your scalability. So what we want is some way to ask for some bytes and then jump off the thread, right? And there are ways to do this. You could use Java NIO, which is a pain in the derriere. You could use Java NIO2, which is a slightly less but still staggeringly painful pain in the derriere. You can use Netty from my friend and fellow Java champion Trustin Lee over in Korea, and Netty's a much better approach to doing non-blocking I/O, but still a little low level, so then people start using things like reactive programming. But even that, as easy as it is, it's still a different paradigm. You still have to write different code, right? So what we want is some way to make this thing right here, which is using things like input stream and output stream and JDBC and the servlet API. We want that to work, and that's the power of Project Loom, okay? So that's what's just been released in Java 21, and let me just show you that, right? And I saw this great example from our friend Jose Pomar, who's on the Oracle Java advocacy group, right? And he's got this great example, which I will shamelessly steal here, right? Because it is perfect. So we're going to create a bunch of threads, okay? I'm going to create intstream.range 0, 100, so, or 1,000, doesn't really matter. We're going to create 1,000 because it creates contention, right? There's only so many real threads, and I want to handle things across 1,000 of them. That means that at some point, somebody's got to get involved and say, hey, can you share, because I need that thread, okay? Then we're going to create a bunch of threads using that, so I'll say thread, there you go, thread.of, don't do this. This is a mistake. Do that, okay? Okay, and then we're going to create a new runnable, and we're going to create a list, okay? And I'm going to then for var t in threads t.start, and then t.join. So I'm going to say, please yield if you can, okay? Now what am I going to do in this? Well, I'm going to note the threads on which I'm executing. I'll say new concurrent skip list set string, okay? And I'll say static void, string observe, and I'll just thread dot sleep, whatever, 100 milliseconds, and this is going to require a try catch because we hate conciseness. Okay, and then I'll say return. Given an index, if we are the first thread, so if index is 0, then we want to return the current thread to string. Otherwise, I'll just return empty, okay? So I'm going to then note that. I'm going to call observed.add, what did I call it? Observe, yeah. Observe, and I'll pass in the index, okay? And I'll just keep doing that 3 times. So I'm going to now, it's going to run, but each time I'm going to get the current thread. If the index is equal to 0, there's going to be 1,000 of them, so I only care about the very first one. Because what we're doing is we're sleeping, then we're noting the thread that we're on, okay? Sleeping, noting the thread, sleeping, noting the thread, okay? And then finally, I'm just going to print out the values of observe.toString, okay? So there's this right here. Whoop, whoop, whoop. There you go. We don't even, oh, that's so nice. Good stuff. So Command-Shift F9, right? Command-Shift F9. Okay. So there you go. It ran. And you can see, because I'm using virtual threads, the only thing that I changed, right, is I changed this bit right here. I didn't make this mistake of doing that. That would be wrong. I did this. And because I did that, the runtime rewarded me. It automatically detected that I'm doing something that's blocking, like thread.sleep or like input_stream.read, and it's moving the code off to the side, off of the thread, off into RAM. It's monitoring the thing that's blocking. As soon as that thing returns, it puts me back on the thread, but not always the same thread. So, for example, we are on virtual thread 123 for the entire run of the program, but we're on real thread, worker 1, worker 2, worker 8, right? Magically, the compiler wrote that code so that it was automatically moved on and off real threads for the run of the application. We did nothing, right? All I did was do a virtual. You can, if you're using an executor, an executor instance, you can do executor equal executors dot new virtual thread per task executor. It's concise, okay? Even I forget it, and I work on the Spring team. So it's easy. You plug those in wherever you use an executor. But the thing is, there are lots of places in your program where you can use executors. So wouldn't it be nice, especially in a Spring app, right? You got lots of places with your web services, your messaging, your integration layer, all that stuff has thread pools. If you use @async and so on, that all has thread pools. So in Spring Boot 3.2, we have this, whoop, hey, come back. We have Spring threads virtual enabled equals true, okay? So now we'll do that for you. You don't even have to do the virtual part, right? We've done that for you. So now your code just gets this unprecedented scalability with nary a property change, and you get it for free. So okay, great. So we got all that. What can I do now? Well, I want to turn this into a native image.
Will it work with GraalVM?
Yes. Does it blend? So Maven W, P native, P native D skip
native
test.
Compile.
Yep, native compile. I'm gonna skip test because ain't nobody got time for that, and besides, I didn't write.
Fingers crossed.
Didn't write any. Okay, so we're gonna let that run. And normally at this point, people, I usually talk about this time, okay? This is there are two drawbacks to native images that you need to know about, okay? That's what this is our message of hope to you. Two things. First, Java agents don't work. Second, they take a long time to compile, okay?
Java agents do work if you can make them work at build time, right? There is a way to make them work if they are not modifying the bytecode, right? So they work to an extent, right? Things you need to know. But yeah, the build time can take a while for a build your application. So here is the place where I should have reminded you about the quick build mode, right?
Oh yeah, what's that?
There are helpful things. I mean, don't stop the compilation.
I was going to control C.
but we will maybe do it for the next one. So with GraalVM, what you can do as you're still developing your application, you can enable a quick build mode -OB. And this will give you faster compilation times as you're developing your application. So you will get faster feedback on how the application compiles to native. Now, you want to remove that when you're moving to production and you want to have better performance because this will give you faster builds, but slightly less performance at runtime. This is only a developer kind of experience mode. But this -OB will speed up, thank you, Josh, will speed up the compilation times for you as you are still compiling your application, and you want to see that how it works and how it compiles to native. So we should have done this in our build arguments, and we can do this for the next one. But see, as we were, talking about how long it takes, it's done.
Yes, it is done. Okay, so There we go. 1 minute and 16 seconds, or 11 seconds, I mean. So there's the binary, du minus hs service. Okay, 89 megs. That includes the code, the runtime, there's whatever code I needed from the JRE. That's all there, right? So it's 89 megs, but you don't need to deploy a JRE now. In fact, you don't need it. You probably don't need to deploy a very full-featured Linux distribution either, right? Because you're not using most of the things that the JDK depends on, right?
Okay, showtime.
Okay, so we've got this application, but remember, it's going to fail, right? Why is it going to fail? Because we have no database, right? I use test containers. I'm doing git clone run, right? So I need to specify that. I need a database, desktop talk, okay, and I'm going to say cd cat run.sh. That's going to run the binary, right? Download service, target service, set up the environment variables, and so on. So we'll do that here, okay? Run. Yes, that should work. There you go. Oh, I didn't set up the Docker. Okay, so I have to do Docker compose up, and then cd desktop talk cat run, still there, good, run, there we go. So there's the application, 0.108 seconds, right? And we got the virtual threads going, thank you. And we have an application, we're using test containers, and we're using Java 21, all that good stuff. So it just works. That's the message to you, friends. For the 80% case, this should be, for the 99% case, this should be your experience of things. What we're going to spend the rest of our time talking about is what happens when it isn't.
Yeah,
okay?
But can we stop here, because they did not cover this in my talk, and talk about working with libraries, right? So you mentioned, about libraries and how they are working, right? And I wanted to mention, if you can maybe open the reachability repo, that would be helpful.
Yeah, reachability.
So we often get this question, I have my app and I want to work with GraalVM native image, but how do I know that my dependencies will also work with GraalVM and native image? So 2 things there. One, there is a page on our website where you can find a very extensive list of all the libraries that we at least know are tested and working exactly with native image out of the box. So that's one thing. And the way libraries can work with GraalVM is either by providing necessary configuration within the library itself. That's the best way, right? So there are cool kits, for example, H2, which we also sometimes show in our demos. So if you look at the H2 and the exact source code on GitHub, you will see that in the source code, they also ship configuration for GraalVM native image, for example, for reflection and other things that native image sometimes needs help knowing about. So those libraries already will work out of the box in native image, just like we showed to you now. But also there are some libraries and tools that haven't yet adopted GraalVM, and for that, sometimes you would need to provide configuration, again, for reflection and more dynamic Java features.
Do you know what else works just out of the box I just noticed the other day?
What?
The AWS SDK.
Amazing.
Amazing, yeah. Like they're providing. I even complained about it on Twitter, as I often do when I'm stuck. And somebody said, "Hey, well, you got me worried that the GraalVM testing that we're doing isn't up to date." I'm like, what? And then said, which version of the SDK are you using? I'm like, well, this one from, 2 years ago, which apparently is ancient.
I mean, 2 years ago, that would do it. Yeah.
So he said, just use the new 2.x release, and I did, and sure enough, it just worked. I got to delete all my code for the support for that. Yeah.
Amazing. So if the library doesn't yet provide config and support for native image out of the box, the next bad thing you can do is there is this GraalVM reachability metadata repository, where, for example, if you are facing a case like Josh did, but there is no support for this library yet in the library itself, even in a newer version, the next best thing you can do is you can enable access to this repo through our native build tools, so through GraalVM's Maven and Gradle plugins. And what this will do is when you build your application, native image will go and look at this repo and try to find configuration for your library in this repository. And configuration here is coming from our community and our team. So if you look at the things, it's metadata. So there are plenty and plenty of libraries where the community, along with our team and Spring and other framework teams, has contributed already configuration for various libraries to work with native image. So it could be, that if you need to provide config, maybe somebody already faced the same issue, has figured it out, and has contributed it. So this repo and access to it will help you build and use many, many libraries in GraalVM and in the native image mode as well. And as you can see here, we have, indeed, many, many contributions from the Spring team. So this is the way to make more and more libraries work with GraalVM.
Well, submit a pull request to their project and make them maintain it. If that fails, then added here, right?
Yeah, that's a very good point. So preferably, if there is some library that you want to work with GraalVM, but it doesn't work yet, ideally, you would go and ask them to provide support and indicate to them that you're interested in this so they can maybe prioritize this. But if for some reason that's not possible yet, the next best thing would be contribute this configuration to this repo so that we can all just reuse it instead of each figuring it out on our own. Yeah, that was about compatibility, and we can go back to our little demo.
Okay, so we've got an application. This is a GraalVM native image. It's running. What's the process identifier? Where's this thing right here?
20 or 71.
Okay.
Oops, drop something.
Right there. And I'm going to measure the RAM very simply using the resident set size. So resident set size memory Wikipedia. Okay. It's the portion of memory measured in kilobytes, so divide by 3, right? Divide by 100. Occupied by 3 zeros, right? Occupied by a process that is held in main memory. So RAM, basically, okay? So there's the number. Take off the last 3 numbers there, digits, and you get 111 megabytes of RAM, right? So this application is now using Project Loom, which means that it'll handle considerably more requests, right? We should have tried that with that demo you did earlier. That throughput would be a lot higher, right? Thanks to Project Loom.
It was already pretty cool, but yeah,
very
you should
good.
give it a try.
Yeah, but that one little property gives you, it unlocks even more concurrency, more scalability, more throughput, and it takes 111 megabytes of RAM. For reference, like, I don't know, what's a...
I like what you did last year with James Watt, right? So you asked how many of you here in the room have maybe Java applications that have 1 gig of RAM?
Oh yeah, how many of you have, how many of your apps take a gig of RAM?
Okay.
Oh, you're
quite a few people. So here, imagine that you can deploy 10 such apps for the same memory usage, right?
Right. Okay, wait, here's IntelliJ, which is my friend, but also my enemy, right? 3.8.
I mean, it's been a lot of work, right? You
Yeah.
know.
So this year I'm trying to switch to Safari. See, I'm making an active effort because I got so tired of, like, let's hear it, Chrome. Start.spring.io, okay? Chrome. Okay, there. What is going on? Why? Right? What just happened? I launched it a second ago, and we've already gotten to the point where I'm probably close to a gigabyte, and I don't even know why. What is all this doing? Look at all this. 368 megs of RAM all the way down. So this is taking almost 4 times as much RAM as my super scalable, super robust, super available, super fast, super lightweight, production-worthy Spring Boot application, right? So yeah, there are a lot of ways to spend a lot more RAM on your operating system than what we're doing now. That's an amazing place to be in the Java ecosystem. Okay, so let's talk about the basics, I think. Let's
Basics.
peel it back a little bit. Let's go back to the basics because
We talked about some of the crazy stuff. Now we can go
Yeah.
back to the basics.
just so
Okay,
we're on the
let's
same
do it.
page. Like the TLDR should be and is that if you're using Spring Boot 3.2 and Java 21 and GraalVM, there's no
Everything just works.
Yeah,
Everything
yeah.
just works.
You've never had a better time, right? It's just been an amazing time. And like, think about this, right? This I often ask myself, this is a hypothetical kind of question. Don't do this. Please don't do this. But what would it have taken to build Kubernetes in Java, right? And again, nobody's going to do that. That would be ridiculous. There's like hundreds of millions of hours of R&D poured into it. But imagine you're in the room and you could time travel back into the distant past, back in 2013 or 2011 or whatever it was, and be in the room with the people building Kubernetes. They made the choice to use Go. What would they have needed to make the choice to use Java? And I kind of think about that a lot, right? Hypothetically, right? You would need highly scalable concurrency, right? That's Go routines in the Go world, but now we have Project Loom, thank you. We have small, super fast, lightweight native binaries, self-contained native binaries. That's GraalVM. And then we have, of course, easy interop with the operating system, right? With the operating, like, low-level features. And that is Project Panama, which is not here, but should be, as far as I understand, if everything goes to plan. I think they're targeting 22, right? Like less than 6 months from now.
And also, it's coming to GraalVM.
Right.
Actually working on it, so, should be coming back soon as well.
So that's less than 6 months from now, and you've already got this. And this stuff you can get done. You can just, whatever. This part is, okay. So that's amazing. Like you could build these kinds of things. In fact, you wouldn't believe it to look at me, but I'm actually a contributor to Kubernetes. And one of the things I worked on was the AOT and auto configuration support for Spring Boot 3 to the Kubernetes Java client. So if you use the auto config there for the Kubernetes Java client, you can build controllers and operators and clients of all sorts talking to Kubernetes and using the Kubernetes API and controlling other things in Kubernetes using Spring Boot, right? And these apps now take 20 megs of RAM, 30 megs of RAM, and they start up in milliseconds. I mean, truly an amazing thing now. These things are every bit at home on a Kubernetes cluster, managing other Kubernetes things as anything in Go or anything else like that, right? So it's just an amazing opportunity thanks to GraalVM that we have right now. So okay, with that, the future is rosy.
Here.
It's here, but sometimes things will go wrong. And what we want to talk about is where things go wrong and what to do. But in order to kind of like make that jump, we need to do a little Spring 101 here, okay? Like this is all the high-level stuff. Everything's working just fine. I've hopefully persuaded you that the high-level stuff works just fine. But let's get a little low-level here, okay? How are we doing on time? 110. Good.
Do we want to make a break, or do we want to make it later?
10 minutes. Go.
You're not very convincing.
Yeah, well, should we do a 10-minute break?
Or should we do it later?
I think it's a good time to do it now. Yeah, go do it quick. I didn't realize we're so short on time. We've got so much more to cover. Like, time's a wasting.
Okay, see you in 10 minutes.
10:51.
Amazing.
Oh, God. Oh.
So welcome back to the second part of this talk. We are glad to see you here. We are glad that you came back after the coffee break. Yay.
Yay. We got Java. Okay, so
now in this second part of the talk, we will talk about what to do when things get tricky and challenging, right? So we showed you the happy path. We showed you a quite advanced application that just works with GraalVM out of the box. But sometimes in those weird, random, niche cases, it could be that you will hit some limitation and you would need to make things work manually. So there are things you need to know about for that, and let's go through them. For that, I want to take a quick step back and talk about native image and how exactly it compiles your application, because that will affect those things you need to know. So unlike your normal Java application, native image, what's going on there? Oh, we're looking at the search results.
I don't know. Yeah, what do you want me to show? Yeah,
it's fine.
Matter. We're just talking.
Yes, so the way native image compiles the application is ahead of time, right? So unlike JIT, where things happen and your code is dynamically executed at runtime, native image compiles the application ahead of time. And to be able to compile the application ahead of time, there are two things that native image needs. One thing is that it needs to know everything there is to know about your application at build time. So it needs to discover your application and everything that happens in your application at the image build time. And it will do so under closed world assumption, because otherwise there is no way to limit what happens at runtime. So everything there is to know about your application needs to be known at build time. And then what native image will do, it will include only the parts of your application that are reachable, so the ones that are actually being used and do some valuable work, actually being executed in your application. Only those parts of your application will be produced and compiled and included in your native executable.
How does it determine reachability? What does that mean?
Yeah, that means that native image will look at your application, starting from its main entry point, and it will look for all the reachable code paths, trying to find exactly what is happening there, and then it will only include that code in the native executable, and it will eliminate everything else.
And it does that only at compile time with static analysis, right?
Yes. So this happens in compile time, and it applies not only to your application code, but also to all the dependencies and all the GDK classes. And this is done so that in the end, the application can be very fast because everything is pre-compiled and included and discovered, but also it can pose certain challenges. So this happens ahead of time, as I said, and there are those limitations in place. And some people call this limitations, so this ahead of time closed world assumption, but I rather see it as a different design and architecture choice, because, for example, this enables this fast startup and low memory usage. So we discovered everything there is to know the application at build time, and then when you actually run your application, there is none of this warm-up overhead work to be done. Because if you run your application on the JVM, what needs to happen every single time you start your application is that you would need to load your classes, look at them, start interpreting, start profiling, compiling, And then eventually, when your application warms up, it can run with the best optimized peak performance. So the idea of native image is to move all of this overhead code execution and compilation work to the image build time so that you can do it once and then run really fast every single time when you're executing your application. And because of that, some of more dynamic Java features, such as, for example, reflection, pose a certain challenge for native image because under closed-wall assumption, normally there is no way of knowing what exactly you will do using reflection at runtime. Now, there are good things about that and things more to know. So how many of you have heard GraalVM doesn't support reflection? Okay, quite a few, unfortunately. I still have a lot of work to do. So it does support reflection, but there are things to know. So one is that normal, more predictable reflection calls, native image will figure out on its own. So this is already included in native image. We will see an example in a second where reflection calls that are a bit more predictable, kind of make sense. Native image will figure out and resolve on its own without any help from your side. That is one case. Now, in case when things get a bit more tricky and unpredictable, there are more things you could do. One is that native image comes with a tracing agent that can observe your application behavior at runtime and produce configuration that can be used to tell native image about what exactly you want to do in terms of reflection, proxy, serialization, etc. And then this reflection can be used at build time to build a native executable that is aware of this dynamic behavior and where this dynamic behavior will also work at runtime. Also, you can produce such configuration manually, and we will show you how. But that is probably not the most exciting things to do because that requires writing some JSON files. So normally what you will want to do is run with a tracing agent or have those things like reflection, etc., provided to you in the form of configuration from the framework, library, etc. So those things work, but those are the limitations that you have to keep in mind, and we will show you how to make them work. Hopefully you will never need anything of what we will show in the next hour and a half, but just in cases you will hit one of those corner cases, we will show you how to make those things work.
Yep.
Okay, let's see how we can or do we want to do Spring Basics now?
Yeah, we got to do some basics because there is a way that you can get around all these things in Spring. And we're going to talk about the underpinnings in GraalVM. We're going to talk about them in Spring. But to understand those things in Spring, I don't know. Actually, we can find out. How many of you have been using Spring since it was just Spring and not Spring Boot? Since before Spring Boot? Okay, so a good many of you will understand some of this stuff. We're going to very quickly recap here. But some of you won't, right? There's a lot of you, actually, that I just saw that didn't raise their hand, which is good. That means that Spring Boot has created new community where there perhaps wasn't before. So we're going to go ahead and just, again, going back to basics here, start.spring.io. All I'm going to do is use Java 21 because I need it. Just feels much better to use that. I'm going to use GraalVM, and that's it. Okay, we're not going to build a full-on app right now. We're just going to use the latest and greatest in Spring and Maven and all that stuff. But again, everything I'm doing here, you could have done with Spring Boot 3.0 and Java 17, right? It's just, if you have a choice between Java 21 and 17, I don't need to tell you Java 21, just judging purely by the version number alone, is bigger than 17. Okay, so I'm going to hit generate, open this up. Okay, UAO demo.zip. Okay, very, very quick primer here on Spring 101. Spring absolute, this is stuff I don't really have to talk to people about usually, except when we get into the weeds of this kind of stuff. So let's talk about Spring Framework, okay, and AOC and AOT, not AOC, that's the senator. AOT, okay, so we've got this public static void main. We've got a application full of objects, right? And so it used to be, back in the old days, we would have something called an application context, right? So app context equals new generic application context. It's still there, obviously. And actually, you would use a subclass like annotation config application context. And then that, in turn, would take a configuration class. Or you would use the XML application abstract, there you go, class path XML application context, and you'd give it an XML file, right? So let's just say I'm using Java config, and I say static class my config, right? and I'd give it this class. I'd say myconfig.class, and then I'd create the app context, and I'd say start, right? Now I've got an app context, and let's say I've got a configuration in here, configuration, and 2 Java objects. One is called whatever, class foo, class bar, and final bar, okay, as a constructor argument there. So I'm going to tell Spring about these 2 different objects. They need to talk to each other. They relate to each other. And one depends upon the other. So I'm going to use those 2 types. We're going to wire their relationships up in Java config. So bar, this one, new bar, and then foo, okay? Foo, return new foo, passing in a pointer to bar. So I can inject bar like that, or you could call the method. You could say this.bar, and then Spring would inject it, okay? So I prefer to do the type via the injection, the parameter, right? It's just cleaner to me that way. And also the signatures of the methods make clear the dependencies, right? I like that. So I depend on a bar. There's no guarantee it's going to be this bar. It could be some other bar. I might have a qualifier. I might have something like this that says, hey, it has to be my other bar that's in some other module, right? In which case, this bar, which is just named bar, right? This one wouldn't qualify, right? Okay, so this is very, very simple Java configuration. I'm injecting one thing into the other, and I'm telling Spring about the relationships, the wiring in this config. And now I can say app context.getBean bar.class bar, okay? And then system out and bar to string, okay? Let's run this program and see what we get. Oh, it's already running. There you go. So we got the one object, right? There's the one thing. There we go. So it's pretty trivial. You've got objects that know about each other. And at the end of the day, when you create a Spring application using Spring application.run, and you pass in this Spring Boot application, let me see, get rid of that. Demo application.class, pass in the args, right? .class. Okay, so there's my Spring application.run. At the end of the day, this is going to give me an application context, right? I have the same bean factory as I had, almost 20 years ago, basically, right? Same application context reference, and I can do the same things with it as I would before to get the reference to the bean. So but now I've got a whole bunch of other nice things that are happening for me automatically with Spring Boot. Let's talk about that, okay? Let me just run this to make sure we're on the same page. Okay, there we go. I got the bean. Now, this is a Spring application context. I'm getting access to the beans. We're using Java configuration, but also we could use component scanning. So let's say that my Spring bean here wasn't explicitly wired. Let's say that I got rid of bar here, but I added a component scanning annotation like this, add component. Okay, let's rerun the code. This is a stereotype annotation from UML, right? It's saying to Spring, hey, I want this bean to automatically be configured, and I want you to use the obvious constructor, right? Which is going to be the either noargs one or the one that has parameters whose types are resolvable by looking at other beans in the context, right? So if I rerun that again, you can see it says hello bar. So now I'm using component scanning and I'm using Java config. Well, I can also do XML, right? I don't recommend this, certainly do not recommend this, but you could do XML. You could do this, you could do like file, new, Spring, I don't know how to do this anymore, XML config file, Spring config, y.xml, and I'm going to say bean class, what is it, com example dot demo dot, what did I call it? Let's make this public so that I can find it. Okay, down here, and foo, okay. So now I've got this thing I'm going to configure. Oh no, I have to make it a bar. Let me make this bar because that way I don't have to worry about collaborating objects. Bar needs to be down here. Okay, get rid of that. There we go. Okay, so I've got my foo and my bar. There is no Java config, is that still true? No, there is. There's this right here. So the bar will be configured here. Okay, and the foo will be configured here, and the foo is going to inject a pointer to the bar, but they're being configured in different contexts or different places, okay? But they still work. Oh, whoops, bar. Oh, I have to import the XML, of course. So where do I do that? I guess I can do that here. Import resource, y, whatever, y.xml. Okay, there you go. So it worked. I've got the bar. That got configured here. And the reason that works is because Spring doesn't care about XML or Java config or function, or your component scanning or whatever. At the end of the day, it has just a big bag of beans, right? A big object graph full of bean definitions. There's also another way that you can contribute beans to the object graph, and that's called functional config. How many of you have used functional config? Anybody? We released it in Spring Framework 5. Yeah, Spring Framework 5 in 2017. So, 5+ years ago. And the way that works is you get the context. You actually change the way you create it. So I'm going to create a new Spring application builder. Whoop, and I'll say main will be, sources will be the demo application. Okay. And then the initializers, that's what we do. New application context initializer, passing an initializer, and then you run it with the arguments, right? So I'm doing the same as before, but now I've added this initializer here, okay? And this initializer, it can be a lambda, of course, but we'll leave it for now like this. So I say AC dot register, configurable, it's got to be a annotation context, generic application context, right? Generic. There you go, this one, okay? And then this, and I can say AC register bean of type. So let's get rid of the XML. It's just makes me sad anyway. Get rid of that. Get rid of this. So now we're gonna functionally register the bar here like this. We're gonna say bar.class, and it expects a supplier. So supplier, a Java 8 supplier, okay? There you go. So now I'm telling Spring, hey, I've got this other object. It's of type bar, but when somebody asks for it and you need to define it, it's a bar.class, and the way you construct a new instance is to call this supplier. So I'm functionally registering it, okay? It's still doing component scanning, but I'm also augmenting the configuration with this functional config, right? So there you go. There's my bar, hello bar, all the stuff that we did before. So you can see at the end of the day, there's all these different roads that all lead to the bean factory, okay? And in the bean factory, you have a bunch of objects that you can work with, but before they get turned into objects that you have in your actual live program, you have what are called bean definitions. And you also have as part of using Spring, and this is again something that's a 20-year-old thing, right? Remember, by the way, that this year we celebrate 20 years of Spring. Did you all know this? Did you all see this? 20 years of Spring. So this is spring1.io, history of Spring. And so you can scroll. There you go. Whoop, yep, yep, yep.
Almost there.
The keyboards are a little fidget. It's better in Chrome. I hate to say it. There. Rod Johnson, Jürgen Holler, and Jan Karoff start the Spring Framework open source project. Early access builds of Spring Framework were in 2003. Here we are, 23. So that's 20 years later. Spring 2004, GA 1.0 Spring Framework. So, okay. Now we got the star power, Spring Security. In 2008, we got renaming it from CG, which is the original project that became Spring Security. Then 2011, we get Spring Data. Spring Boot 1.0 is GA is in 2014, but we had early access release builds of it in 2013. So this year is also 10 years since Spring Boot 1.0, the early access releases of Spring Boot. Then we get Spring Batch, and we get Spring Integration, and then we go up, and we're in the clouds, okay? Was that not subtle? Spring Cloud 1.0 was released in 2015. Providing tools to quickly build software for distributed systems. Spring Cloud Task. Whoop, whoop. Yes, Spring Cloud Stream. Spring Cloud Data Flow going down. Okay, Spring Cloud Data Flow for Kubernetes, right? The maritime memes and all that, right? All the whole aesthetic of like maritime and oceans and all that. So Spring Cloud Data Flow for Kubernetes. We're in the water, right? Kubernetes is Skipper, right? Okay, Spring Cloud Gateway, Spring Boot 3.0, that's last year, Spring Framework 6. Okay, beautiful. Thank you, Spring, congratulations on 20 years of innovation, etc. Okay, so all that to say, the stuff we're looking at here has been there basically in this form basically since 1.0. The application context, the bean factory, the Java config came later, but the XML was there. The functional config came later, but basically this all gets normalized into bean definitions. And you can work with the object graph at that early level if you want. You can register objects of type bean factory post processor. So static class my, by the way, I wanted a quick tangent. This style of working is Java. In Kotlin, which I'm not using at the moment, but in Kotlin, it's really, really nice. So you say val context equals beans, right? And then you have bean, and you would just do bar, right? And that would get you the same exact result. And you would say add initializers, context, okay? Very nice syntax, because we have a DSL there. But basically, it's doing the same thing as this. Okay, so we've got this, let's create a class that when the application starts up, sifts through all the beans and looks at their bean definitions, okay? So after we've ingested all the configuration, all the XML, all the component scanning, after we've realized all the different inputs and normalized them into bean definitions, then we want to work through those bean definitions, okay? So static class my bean factory post processor implements bean factory post processor. Gonna take this.
So this is when we want to work with bin definitions, right? If we want to change something about those bin definitions themselves.
Exactly, and or just to inspect them, or yeah, exactly. So here I've got a chance to look at the whole bean factory, and this is sort of like the primordial soup of your Spring application, right? It's not yet live objects. There's no real objects yet, but you've got meta objects, meta model objects. So you can say bean factory dot get bean definition names for var bean dn. There you go. System out. Special. Oh yeah. Okay.
Yeah, I think we're skipping through stuff. So.
Well, this is the. Oh, well, we're gonna get to that in a little bit. This is like the foundational stuff. So okay, don't worry. Bean factory dot get bean definition. BDN. So I can actually get the bean definition, and then when I have the bean definition, I can get the, the scopes. I can get the resource definition. I can get the bean class name. I can get the factory bean name. I can get the constructor arguments and the dependencies and all this kind of stuff. Very low level, but I can do that, right? So this is a callback. I'm going to register this callback in my config here, and I'll say. And by the way, I no longer need this, right? I'm going to just use Spring Boot application. Spring Boot application is ultimately just at configuration. So if you look at this, it has at configuration on it. So it is therefore at configurable. So now bean factory post processor, new, there you go. Okay, so I've got that. So now I've told Spring to run this. Oh, I have to make this static. So things that get run very early in the lifecycle, in Java config, you make them static, okay? Okay, so the application started up, but now you can see it printed out the names and the class names if they're available, right? Sometimes they're null, that's fine. So we got a lot of stuff there. Let's see. Space, rerun. Okay, the application started up. There we go. The names are, sometimes the names are the class names, which is confusing in this case. There you go. So the task execution auto configuration is a Spring Bean whose class name is task execution auto configuration. Okay, so the bean ID and then the class name there, okay? And where's the one that we just worked on? Our bar and foo, bar. Over here. So here's the bean ID for our bar. It's called bar, and the class name is called com.example demo bar. So you have this bean definition, you have these bean names. This is very low level, but you can do things with this, and we'll see this in a little bit later. You can actually you can use subclasses of this to do things like replacing beans, or adding new beans dynamically. You can programmatically build a root bean definition, right? So root bean definition dot, whatever is it, builder, I guess, or new bean definition builder. Yeah, you can actually just instantiate them manually. There's all sorts of stuff here, okay?
So the reason we are looking at this is because when you start your application, normally all this happens at runtime, right? You start your application and Spring wants to understand what it's doing and what's supposed to be happening. So when you start your application, all this configuration gets discovered and Spring gets this meta model of your application.
Right.
But normally on a JVM that happens when you start your application. And this exactly doesn't work for native image because we need to discover all of this at build time. So we need to know everything about the application at build time. So we need to find a way to discover all of this work that Spring normally does at runtime at build time.
Right. And especially in this case, because we're dealing with bean definitions. This shouldn't be, by the time the program is starting, that graph of bean definitions needs to be static. It needs to be fixed, just like you said. So something is required here. Okay, moving forward a little bit. So this is one of the earliest lifecycle calls you can participate in. There's also bean post-processor. So bean post-processor. And here you get two callbacks. One to change, you can change objects here, right? You can actually, like, let's say I only want to work with after initialization. So I can create a BPP, return new BPP, and just to be sure, I'll make it static. Okay, so here, my job is to look at the current bean and the bean name. So this is the actual live fire object before it's after all the dependencies have been satisfied, after the constructors have been called, everything, but before it's been put into, before the service has finished completing its initialization. And here, I can look at the bean. I can say, okay, if bean instance of bar, right, for example, maybe I want to do something. Maybe I want to create like a static class bar wrapper, or implements bar, or extends bar, and I have a delegate, right, or something like that, but bar, right? Final bar target, or delegate, or whatever. Okay, this dot delegate equals bar, and maybe I have a toString. Okay, and maybe I want to override my toString, my custom toString. So right now we've been using the hello bar. So now I want to just, if it's an instance of that, I'm going to override the bean. I'm going to say new bar wrapper, passing in the bar. And so in every other way, it's going to be a bar. It's just I'm going to override the default for the toString. Okay, so when I inject the bar later on, we should see not the existing bar, but my custom toString. Okay, so I'm able to do that. And the code is exactly the same here, right? I've got a bar. It just if I put a breakpoint here, because I've got that bean post processor, I'm swapping out objects at initialization time. So I'm injecting a bar, but I actually got I did the old switcheroo right before the application started up. Okay, good. So now you understand Spring has these bean definitions, and you can interact with the bean graph right before the program starts. Okay, this is 20-year-old kind of stuff, but it's very important to understand so that we can look at the new stuff. Sometimes things are going to break when you do AOT.
Yeah, should we talk about AOT in Spring and compile versus runtime?
Yes.
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 So as I talked in my part is that now we have this important concept of compile time and things that need to happen and be discovered at compile time. And there is now also, since Spring Boot 3.0, there is this new AOT engine in Spring, which will optimize and prepare your application for GraalVM. So what this thing will do is, it will take your configuration and translate it into functional configuration that is native image friendly. And what it will also do for you, it will produce all those necessary additional files for GraalVM. So it will produce source code, bytecode, and those config files to make your application more easily recognizable for GraalVM. This is coming from Spring. This is this new AOT engine. And we will show you how to work with this and what you need to know about it.
Yep. Okay, so clean that up a little bit. Don't need that. So we've got the Java config for the foo. We've got the, how do we define the bar? Oh, we did that functionally. I'm going to make that at component now. Okay, so let's just compile this. Yeah, there's a new AOT engine. We've already established that all the beans come from something. We looked at functional config. We got regular two objects here. Let's just do.
But let's maybe do the quick build since we are here and we want to compile stuff.
How do you?
I don't know, but just go to POM.xml and add this quick build mode, so maybe this happens a bit faster. So in the native maven plugin, you add build arcs and a build arc within that. Yeah. Yep, and a build arc. No, but like I think that's build arcs, and then you need like a build arc for this particular arc.
Are you hey, please?
Okay.
Help me.
Let me see, but I think this has to be like a separate thing. Let me, if I can remember this. Build arcs. I thought it was supposed to be one more build arc. Oh, it happened. Dash OB, but I think, can we try if it like accepts a parameter build arc, not build arcs?
Oh, okay, here. So put that here, and then go away.
I mean, we could try like this, but I think it should be a build arc. Yep, yep,
Like that?
yep.
Okay, so now -p native d skip tests native compile.
Yep. Oh, it picked up our quick build mode, so this should be fine.
Okay, so it's gonna go faster. Look at this. It's one thing you have to be aware of is that it takes a whole slack of RAM.
But we will not take out too much RAM. We will look at your machine and what is free, and we will, occupy memory based on that. So you can run your Slack and you can run your Chrome and whatever else you need to run.
I have.
I mean, you have a good machine.
I was just about to say I have one of the creakingly old, ancient 2021 machines. Apparently, Apple are now selling Slack-sized M2s that support 96 gigs of RAM, which is, amazing. Okay, so that ran 38 seconds. Target demo. There we go. So, right, 0.023 seconds, hello bar. And
Amazing.
this, of course, took no RAM at all, basically. Took like, whatever, megabytes. This is a very small application, so I don't know if the quick build bought us much.
I mean,
there's nothing here, right?
One thing to know about it is it will only speed up the compilation stage. So as you've seen, there are about 8 steps to this whole build process, right? And this only affects the compilation step. But if you're compiling something bigger, like maybe path cleaning, this becomes a bit more substantial.
Right.
So do we want to talk about configuring custom things like resources, reflection, etc.?
Let's do it. So can I leave this on? I guess I can, huh?
Yeah,
so
why not?
I'd be interested to see what the difference in time is. But again, it's such a
but
small
it's a
application.
small application. You need something bigger.
Yeah. Okay. Okay. So we've got this basic application. Everything's fine. Where you start to get and just keep in the back of your noggin all the stuff we just looked at when it comes to the core component model. We'll get to that in a second, but you need to kind of understand that to understand everything else sort of down the line here. But there are some things that that are being done for you. So we just use the AOT engine to compile the code. You can see here that the code, the AOT compiler, actually generates a bunch of stuff here, right? It generated all the reflection configuration and resource configuration and some extra properties there. That it generated Java code, right? It generated all sorts of stuff for us, and we're going to get into all that is. But suffice it to say, what gets fed into the compiler is not the same thing as what we wrote, okay? That's the AOT engine at play. And the AOT engine does a lot of work for us. So you'd be surprised how much we'll just work out of the box despite having these sometimes, different modalities that you have to care about when you work with GraalVM. Like Alina said earlier, it's a different architecture, right? And it does a lot of static analysis. Well, of course, things change at runtime. Java is and has always been a very dynamic, runtime-centric sort of platform. So there's a what's that word? Impedance mismatch, right? The way that Java operates and the way that GraalVM wants to operate are not exactly the same thing. You can bridge the gap through configuration, but the AOT engine will provide a lot of that for you, okay?
And I want to say one more thing since we are looking at the AOT-generated stuff, right? Mm-hmm. So there is also a way to run this AOT-generated code on the JVM as you are running your Spring application, right? So it's done mostly for the native compilation, right? But if you want to quickly validate that your code is running in this AOT process mode, because as you've seen, Spring generated a lot of things for you, there is a mode of operation in which Spring, I think it's Maven, Spring Boot, and either process AOT or AOT process, one of those two. So what this will do, it will run this generated AOT processed app on the JVM, so you can have some more confidence that it will work also in native image. So I'm not saying that this is running on the JVM with the native images closed role assumption. It's not like that, but it will give you a bit more confidence that the AOT processed code is working as expected. So what you can do, there is this AOT process mode in which you can run your code on the JVM, after applying Spring's AOT transformations and validate that it's working on JVM. And this will give you a bit more confidence that it will also work on native image if you want to have this even faster kind of feedback loop. Do you want to try it or?
There you go. So I just ran it with
Norm.
Spring AOT equals true, minus jar, passing in the target. And it's now using this transpiled code, okay? We'll get into what that code is in just a second, but now let's start working through some common pitfalls, and eventually we'll have to understand the AOT stuff. But for now, you'd be surprised what you can get away with. Okay, so first things first. What if we just try and load a resource? You and I, we even did that. We even tried to use XML here, right? I'm not proud, but it happened.
And it worked.
Yeah, well, it didn't, because I got rid of the Java code, right? But like if I added that back, right, and it was called y.xml, okay, and let's say it was it bar? Yeah, it was bar. So now I'm going to rely on the Spring XML to provide that definition, okay? So let's make sure it works as a run on runtime and JRE. Okay, great, it worked. What about if I compile to GraalVM, okay? Clean. You know what I should do? I should actually.
We should have brought our random facts about GraalVM.
Oh yeah.
For the compilation.
Chmod AX.
The run script.
Emacs run.sh. User bin env bash. And then maven w p native, not naive, skip tests. Native compile and
run
target. What's the name of the program?
Demo?
Demo, yeah, thank you. Oh no. Oh no.
Demo X.
Whew. I escaped. Okay. So target, demo. So that actually worked. Okay, good. Well, never mind.
But apparently you don't need any configuration at all. Things just work.
Problem solved. But no, but there are some things that will not load.
Yes.
What's a good example? Why did that work, actually? That's pretty great. It's getting better and better. It's getting harder and harder to bump into these issues, which is a bit of a pity. I guess it's because we have it here. But what if I tried, like, this text file, random hello, right? Hello. Okay, so now, okay, hello.
Could it be because it's in the annotation and you just want to call it from some random class?
Try var in equals new class path resource. Hello dot get input stream, and then.
See, it takes us time and effort to hit those, issues and make things break. That's a good problem to have.
Right. So
we're trying to break things and we are failing.
Copy to string in. Okay, so system out. There. So I'm going to run this. This is just going to read some contents from the text file at startup time. Okay. Run it on the JRE first. Good. So that worked at runtime. Now we go to the compiler. Run. Come on.
Is it the elevator music yet?
Our friend Fabio's in the house. He's in there.
Is he somewhere in the room? You can oh, he's waving back at you.
Yay. Our friend. Okay, one. Oh.
You have a good machine. I'm sorry.
Yeah. But 10 threads, that's pretty cool. Okay, come on.
Almost there.
Okay,
let's see if we can make things fail.
It
and
failed.
finally, took us 2 attempts, but we broke things.
Okay, so what's the easiest way to fix this, right? Well, the default way, absent any other particular input, is just to write config files, right? And where do you put that config? In the source main resources, meta, not the company, inf, native image, and then you have a group ID and an artifact. So this corresponds to your group ID and artifact, whatever. I'm just going to use group and artifact because I'm great with names. I'm going to use resource config.json, okay? And then in the JSON file, I have resources, and then includes. How am I doing? Yeah, so far so good. Nope, bracket, square bracket. Okay, and then pattern.
So again, we hope that you will never have to do this manually. We are just showing you how to do it so that you have an idea, but preferably this will be coming from your framework, from your library, from the tracing agent. We just want to start with the basics about how you do this kind of thing manually. But we hope that you will never have to do things like we are doing right now yourself manually.
I truly, truly hope you don't. This is like, you know, this is the JavaScript to WebAssembly, right? It's the low-level format that nobody would ever express manually by hand.
But I mean, it's not that bad, right? So the config file is not that scary. It's just not the most pleasant thing to do. So we will also show you how to produce such config automatically.
Nothing is as bad as JavaScript.
What about PHP?
I take it back. There's one thing that's as bad as JavaScript. I stand corrected. Okay, there we go. It worked. Huzzah. Okay, good. So
it wasn't that bad, right? So this is how you would do config, but this is for a smaller application, right? So maybe you can get along by writing it, but for something larger, and especially if you have dependencies, probably you wouldn't want to write those things yourself manually, and there is a better way to do it, and we will illustrate it on our second favorite topic, and that is reflection.
Yeah. So this is, we're going to call this resources. Let's create a new thing here to do reflection. Okay, so this one's actually even harder to break because they just keep fixing stuff and it gets better and better.
I'm sorry, Josh. Yeah, we keep fixing things. I'm sorry for that.
Better and better every day. And actually, I had a hard time in the very beginning because I know this is going to sound counterintuitive. It's better to assume that it's not going to work and just fix everything because they keep adding new things that mean that maybe it's not necessary, but I don't know where the bounds of that are. So like, let's say I have a class. Class.forName, and I'm going to have I don't know, whatever, record, okay, and then cat string name, okay. So the cat type, put that down here. It's com example demo cat, okay. Okay, I'm going to get a class literal for that thing. And I want to get the class name. So first of all, class should equal null. No class. That's probably true every which way. Even no matter how you parse the sentence, it's probably true. Okay. Wow. Okay. Okay. Good. So class.getName. Okay. Okay, so so that'll work. That should work, right? It even works if you do like I tried doing this or like true. Otherwise that, right? I tried like throwing things into it and just sort of I don't know how it works, but it does figure out that I'm trying to load this class, right? And so that's what I'm saying. It's very hard to break this. Okay, so let me just try that, and then once I've got the class literal, can I do all the usual class literal tricks with it? Let's try. So instance, I'm going to say cat class dot get declared constructors 0 dot new instance, and I'm going to pass in Felix. Okay. So now I'm going to create an instance of that class. System out. The cat's name is instance. Okay. Dot name. Let's try that. So on the JRE, does this work? Let's try it out. And okay, the cat's name's Felix. Fantastic. Wow. Okay. What about on the compile time? Okay. So dot run.
So what will happen here is that we will need to discover your application and what exactly is happening there at build time, at the compile time. And some of the reflection calls, as I said, native image will discover automatically because there is support for reflection in native image itself. So if you're doing something a bit more predictable, like looking up the class and its methods and fields, that much native image can understand. But then if you want to do something tricky or just do some crazy reflection for fun or because you have to, that can be more challenging for native image because closed world assumption.
Yeah.
Okay, let's see. We broke the thing.
But
we managed.
But not all of it, right?
Not all of it, no.
We got the class literal. That part worked. It can give us a class literal, but that class literal is kind of, it's not fully there, right? So you can't do all the usual tricks you would do with it, including getting the constructors. I can't enumerate the constructors, right? Okay, well, So how do I fix that, right?
So let's try using the tracing agent.
Yeah, I could write the config, but
Why would I?
Why would I? There's tools that can automate a lot of this for us. So we'll go to our build. And here, it's going to go in the Spring Boot Maven plugin. That's this bit right here. Configuration. JVM arguments.
Yep, got it.
Agent lib native image agent equals config output equals target. Is that right? Native image.
Kind of looks right. I mean, you can also do it from the native Maven plugin, slightly easier, but let's give this a try.
Okay, so Maven W. I'm going to run it on the JRE now, okay? Skipping the tests. Clean package Spring Boot run. Fingers crossed. It's just going to run the program.
Until it doesn't.
Oh, unknown config option.
Config output target native image. Let's see if we can do it from
Oh, dear. I forgot output dear. Oh, dear. There we go. Okay. So now, if I go here to the target directory, there's a new folder that we created called native image. And there, it's written all this configuration for us.
So I think we'll see there are a lot of things coming from Spring itself, right?
Yep.
So not specific to our application code, but all that config that Spring does for your application, how it processes it, it's all here. So it kind of looks scary, but don't be afraid.
So
okay, cat maybe in retrospective wasn't the easiest name that
demo.
can be tracked.
There you go. So it found that we're going to create this class called cat. And it's got this constructor that is of type string. So the constructor, we want to be able to query the constructor and that class, that constructor and write to it, right, to use it. So I can now copy and paste this bit right here, and I think it's just a bracket. So we'll go to here, and we can create a new file by hand. Now that we've learned what GraalVM, what the runtime thinks it needs to be able to make this program work, we can just copy and paste that config. Does that look okay to you?
Sorry?
Does that look okay?
Let's give it a try.
Does it blend?
Kind of looks like a lot of brackets to me, but
yeah, I'm so confused. Okay, so we RMRF target, burn it with fire, and then we compile. So we've done nothing besides run that handy agent, and that agent was great because it also gave us, it's a good starting point, right? Remember, Spring will do most of what you need, so you don't really want to you don't want to dump all the stuff that the agent gives you because it's going to capture stuff that, like Spring generates random class names on each run, so obviously the classes that the agent picks up right now aren't going to be the same ones as the next run, and so you want to let Spring do most of that work, but if you have some stuff that you want to make work, you could just write the config files like this, and then immediately just send a pull request to the team working on it with that config file so that it's not your problem. Okay, so there we go. We made it work.
Amazing.
And we didn't have to do the work, which is the important bit, right? Thanks to that agent. Okay, so.
Do we want to talk about centralized way to handle hints for Spring apps, right?
Yeah.
Yep.
Yeah, of course.
Let's do it.
The agent, right? For reflection. The AOT engine, I mean. Okay, so we've got this. We wrote this by hand. But if you're using Spring, and since reflection is such a common case, there's actually an easier way. I've just deleted reflect config. And again, by the way, like how often do you do this? How often are you doing class.forName and getting the declared constructor? This is definitely in the weeds, right? You're in the library/framework level of the API. This is not what 99% of us do when we build our business apps. If you're doing this kind of stuff, then you need to care. That's why we say the happy path is it'll be just fine. If you're doing this very kind of low-level stuff, then you need to care. You know what else does this kind of low-level stuff a lot? Your JSON serialization libraries, right? But even there, if you're using Spring MVC, for example, and you've got a controller method, and the controller method returns a collection of cats or whatever, then don't worry. It's Spring MVC. Spring sees that endpoint. It's already aware of the fact that you're going to send that cat across the back from the method and want to serialize it to be returned as JSON to your client. So it's already registered the hints for you, right? So for the 99% case, even when you are doing reflection, probably Spring sees it. It's only when it's like this code where it's like hidden inside of the bowels of some method somewhere, and Spring has no way of knowing that you're going to do that, right? We don't peer into your method bodies and understand that you're going to do this. So even serialization most of the time will work just fine. But if you are, for example, if you injected the Spring, the Jackson object mapper like that, well, I don't have it on the class path, but if you did, you could add Spring Boot starter JSON, add that, inject that, and then get the object mapper, and then you started doing object mapper.write value as string with instance of cat, then yeah, that's going to fail. So you want to register hints for reflection. You could use the Java agent. That makes your life a lot easier. But once you've got an idea of what is required, the last thing you want to do, like if it's just your program and you might refactor things, there's always the risk that the JSON will sync or it'll drift out of sync with the API. So I can do register for reflection binding cat.class. This is a special annotation in the Spring framework, right? Org Spring Framework AOT hint annotation. It's written by our friend Sebastian, I'm pretty sure. Yep, and I think he's here this week. So if you want to give him a high five.
He's doing another deep dive, right? Maybe tomorrow. So hopefully you can listen more about those things tomorrow as well.
He's amazing. So register for reflection binding. Register reflection for binding, okay? So I got rid of the reflect config.json, and I haven't done anything else. Let's try rerunning the program, recompiling and running the program. I'll take some water.
So as just said, hopefully you'll never get to this kind of thing, right? We are just showing you various weird cases and how to make things work there, but hopefully this is not something you have to do manually, and you can just rely on your library, your framework, etc., to do those things out of the box.
This is, and of the things that you may never have to do, reflection is probably the most likely.
Yeah.
Right, and then resource loading is maybe this number 2. So here I would call this like warm, like, and the rest of it was like cold in terms of complexity. Now we're in the warm area, and then
but
soon
it will
it's gonna get hot.
Crazier if you still have time.
Yeah. So okay, that's fine. Cat is okay. It worked. Great. Ta-da.
So this might be maybe the easiest way to register reflection from the framework, right? Just add an annotation, you're good. And
we like the type safety that annotation gives us. We like the fact that if I hit Control T on my class and I say feline or whatever, I don't know, and then I refactor that, then the hint that gets generated, right, the annotation that is using that, it will also get updated. And the resulting reflect config that the AOT engine generates will also get updated, right? So that's the nice thing about using the Java API here. But this is the first time we've seen that now there is a component model that exists in Spring that gets evaluated at compile time, right? We actually look at this annotation at compile time and use that to inform the compilation of your code with the GraalVM native image compiler, okay? So this is a common special case just for reflection, but for everything else, for all the other things where you might have issues, which include JNI, resource loading, proxies, JDK proxies, reflection, and serialization, for those things, if you have a class or a program and you're doing some of these dynamic things, then we have a type-safe alternative for you, and that's called a runtime hints registrar, okay? And you can implement that, and if you've just got a few places where you want to do these kind of dynamic things, then yeah, register your own hints. Runtime hints registrar, okay? Implement that, good. And this is going to be a class that I want to register with Spring. I'm going to say import runtime hint dot class. Ta-da. Okay, so I'm telling Spring, evaluate this class, but again, where does this get evaluated? Not runtime, right? At compile time. So I've got this runtime hints, and let's say I wanted to just do the registering for reflection the slightly harder way, right? I would do this. I would say hints.reflection.register type feline.class, and I'm going to be asked what kind of reflection do I want to do, because you have that kind of granularity there, right? So
I mean, it's maybe harder, like more verbose than the annotation, but also it gives you more control, more granularity, and also it gives you kind of centralized place to handle all those dynamic things in GraalVM, right?
Exactly.
So if you need to configure not only reflection, but also serialization, proxies, etc., I think this might be the best way to do it.
Yep. Yep. So maybe I want to do only supporting declared classes and declared fields, or if you're like me and you just want to make it work, just iterate, give it all the values from this enum called member category, right? And you can see there are values like declared fields, public methods, public classes, blah blah blah. Okay, it's an enum. You can use that. So I just give it everyone. That way, it's like a, it's a hammer for a tiny screw, but it does work. It makes sure that everything I need to make that class work is there. Okay.
And this reminds me of an interesting question we got the other day about reflection. So like, why not register everything for GraalVM, like all the reflection, all the possible scenarios? Why not register all that in native image, and why not include all that in native image so that things just work when compiled, right? But you don't want to do it, right? Because native image, like the whole goal there is to eliminate everything you don't need, right? And have this small, final, self-contained binary. You could have registered everything, right? But then it like undermines the whole purpose of native image, because the goal there is to only include what you need, and we can eliminate a lot, right?
Yeah.
So everything from your application code, from the JDK dependencies, etc., that you're not using. So if you want to, you could have tried to register everything, but you don't want to do it because in return, native image gives you this chance to eliminate things you're not using. So you could have registered everything, but you want to only register things you really need because you want to contain that like small binary that starts fast, and for that you need to drop everything else.
Right. So I used this for the reflection, and that made redundant this convenient annotation. Well, what about the resource that we had earlier, right? Well, here's that. We wrote that resource config, but now is a good chance to just get rid of that, and we can register it ourselves manually using this. I can say hints.resources.register pattern. I can give it like a wildcard syntax, or register a Spring Framework resource implementation, right? So the implementation in this case, where's that class that we used earlier? Private, it's this one right here. I created this hello, right? Let's extract this out to a variable, okay? Spring Framework resource implementation, static resource, hello, okay? And I'll say hello, okay? So now I'm going to share that same resource definition here. I'll say hello, okay? I'm just going to tell it to register that exact same thing as a hint, okay? And you saw it worked for, by the way, the reflection worked, but now let's do the resource. And the nice thing is, because it's an object, I can pass it around, I can share it, I can have the same references to it, and I can use it in both my runtime code and my compile time component model that feeds into the GraalVM native image. It's refactorable, it's just better that way. Private, it should be final, it doesn't have to be. Private static final, resource hello. Okay. Let that run, do its thing. This is my least favorite part.
This is not too long, come on.
It's not too long.
You just don't have the patience.
I don't have, well, yeah, those are the two same things. Okay, so it worked. Is it me? Is it me you're looking for? Right, it worked. So now we have this nice runtime hint registrar. This is your friend. If you have just a few places where you need to register a resource and a couple of types, then I usually just create one of those. I usually make it inside of a class. That way it's not even public thing. It's just a little bit of glue code, and most of the time you don't even have to worry about it, but if you do, now you know how to do it, right? Okay, well, what about serialization? Serialization is another one of those things where you probably will bump into this if you use the HTTP servlet session, right? Did you know that contractually every object you put in the session needs to implement serializable, right? Most runtimes, most containers will kind of let it slide if you don't implement serializable, but in theory you might have session replication, right? And if you do, what happens? That object has to be serialized and replicated to another node. So, hey, watch. I don't want to stand up. I'm busy. So, let's say I have where's my feline friend? Hello. I'm going to just make this implement serializable, okay? And now it implements serializable. I should do the work, but I'm not going to. So but I want to make sure that it's also registered for serialization, Java serialization, not like JSON serialization, right? So in that case, I say serialization.registerType feline.class. Okay, pretty straightforward. And also you can use the builder to customize, whether the hint is added by adding an onReachable type. So basically, if this other type is there, then and only then should I bother to register this hint, right? And that might be nice if you have like some sort of dynamic auto config kind of thing where you want to dynamically add something, but only if something else is there. Okay, so we I don't know. Do I want to bother with
I think people can trust that this will work, right?
Oh, okay, yeah, okay. Anybody want to see me do this? Okay, I don't want to do it. Nope. You know, don't use serialization. Actually, that's my message to you. Don't use serialization at all. I think I'm not even how many of your colleagues from Oracle and Oracle Labs are here this week?
A lot.
A lot, and I'm sure if you ask most of them, like they'll very, very ardently discourage you from depending on serialization if you can. Okay, so yeah, don't do it, but if you needed to do it, this is how you would do it, okay? Okay, what else? Proxies.
But also, we have 40 minutes left, so I'm thinking, do we want to do proxies? Or
we gotta hurry. Yeah, okay.
Because I feel like this can take us another 40 minutes, but okay, let's give it a try.
Let's give it a try. So, proxies are something where, I don't know, how many of you have ever written your own JDK proxy? Yeah, it's, again, hopefully, again, this is very much not something most people need to care about, but if you want the details on where GraalVM might be different, this is one of those places, okay?
Okay, things are about to get more crazy. So all this reflection config, that was still the easy level, but here we're getting to the real stuff.
We're in the, like Dr. Strange said, we're in the end game now. So, if you write it, let's say I want to write a JDK proxy that logs the time, okay? Something like that. And so you can do this with a, let's say, class JDK proxy logging bean post processor, okay? Implements bean post processor. So remember that thing I showed you earlier that lets you wrap objects, right? And then return them. What I'm going to do is I'm going to create a static object logging proxy given an object O, okay? And I'm going to create a JDK invocation handler. I'll say proxy.new proxy instance. I'll get the current proxy JDK class loader. So get class loader. And I'm going to implement all the interfaces that this object has. So I'll say get class.get interfaces. Okay, var I faces, this one here. And I'm going to pass in those I faces there. And then I'm going to create a new invocation handler, which is like an event listener for when somebody invokes a method on the returned proxy, right? So this is just going to be an object, but you can downcast it to the type that you want, right? Because it's actually going to implement the same types as these interfaces that you've got on your object, okay? So I'm going to say when somebody invokes a method on this proxied thing, then give me a reference, give me a pointer to the currently executing method and the arguments that were passed to that method and the object on which the thing is happening. And here I can say, okay, well, try finally, and so I'm going to return method.invoke O, and then passing the argument. So I'm going to pass in the target object here. I'm going to invoke the method on the concrete type there. And then finally, I'm going to print out finished executing method.getName at system.currentTime, okay? And I'll print out starting executing. Okay, so I'm going to log out when the method was invoked and when it finished being invoked. Okay, so this is pretty typical AOP style, you know, proxy kind of stuff 101. Okay, this has been here since JDK 1.4 or something like that. It's been a long time, right? This API. So now I can use that. I can say, okay, if the bean instance of, let's say, class default customer service implements, and I'm going to do the thing that you should never ever do. I'm going to create an interface that has just one implementation, right? And that method will have void add to cart, whatever, string skew, okay? So implement that, whatever, adding to the cart, okay, very good. Okay, so I've got this now, my at service kind of thing. It's implementing an interface. If it implements customer service, then I'll say return logging proxy for the customer service. Okay? Otherwise, just return the object. I'm not going to change it. So I've got some test that looks for a thing. I could look for annotations. I could look for a type. I could see if it implements serializable. In this case, I'm saying, oh, if it's a customer service, then create the proxy out of the customer service implementation, making sure to preserve all the interfaces, and then automatically add some logging to indicate when the method was started and when it was stopped. And you can imagine how this would work if I were to send it to a time series database or something. Okay? Oops, that's not going to work. I have to run it first. So we go back here and we create this logging bean, this JDK logging bean post processor. I'll say bean static. Okay, return. And then we want to have something that actually does the work so we can see it in action. So we say return new application runner. I'm going to inject the customer service. You can imagine using this in your database or your web tier or something. Whatever, 1, 2, 3, who cares? Right, where's that? Where did it go? Where did it go? It's lost. There, 1, 2, 3, 4. Okay, so when the application starts up, we're going to call JDK proxy, and we're going to call the method, and we should see the log output indicating that we're starting the method and we're stopping it. Okay, so starting that, doing the thing, finishing it. Okay, so the proxy is working. How do we make that work in GraalVM? Well, it's going to fail by default. And the reason is because GraalVM doesn't know that we're creating this dynamic thing at compile time. So let's go ahead and run it and have it fail. So
can we trust that it will fail?
I don't know. This might actually work. Who knows?
But yeah, let's try it.
Yeah. It gets better and better every day, like I said. Okay. Oh. Yeah. Okay. By the way, how many of you have code where you have like an implementation? You have a bean that has one single implementation? And how do I get you to stop that?
No one is daring to raise their hand.
Okay, so yeah, it failed catastrophically. GraalVM is really nice though. It says program tried to reflectively access the proxy class inheriting customer service without it being registered for runtime reflection. Add com example demo customer service to the dynamic proxy metadata to solve this problem. And if I had more than one interface, it would stipulate all 3 interfaces or all 2 interfaces or whatever.
And even links to the website where you can, figure out how to make it work. Super
useful. It almost makes me think they could probably have just done it for me. So anyway,
let's do it ourselves, though.
We'll do it ourselves. I need to do, and I can use that hints class, right? Where's this class here? Here we go. Hints dot proxies, JDK proxies, register proxy. In this case, I've only got one interface, but the order of the interfaces matters. So if you have 3 interfaces, make sure you represent all of them in the order that they are implemented, right? So I'm registering that. That looks okay, right? Basically. Okay.
Quite simple.
Right. Register that. Recompile. So we've done, what have we done so far? We've done resources. We did reflection, the big one. We did
serialization. We talked about it. Yep.
Yeah, for a second.
Proxies.
JDK proxies. Again,
do you want to do Spring proxies?
Yes, I do.
Of course, you want to do Spring proxies.
Of course.
We'll talk about this. Code generation.
Yeah. Don't give away the plot. Oh my goodness. Wouldn't it be funny if the TLDR is that this is just Spring Roo? We've gone back. Okay. So
it worked.
It worked.
Amazing. Just one line of code, right? That helped us figure out that config.
Yay. So we now we can have our dynamic fun and our performance, right? Have our cake and eat it too. Okay, great. So this is a JDK proxy, but again, like I said, I very strongly discourage you from doing. This is an anti-pattern. It smells like 500-year-old fish. Like if you have a class that has one implementation and has an interface, just get rid of the interface. What are you doing? This is a waste of time and conceptually it's just more work, right? Get rid of that, get rid of this. The problem, of course, is that now we have a concrete type, right? And concrete JDK proxies don't work with concrete types. They only work with interfaces. So let's say I wanted to refactor this code a little bit, okay? So now, I'm just gonna copy and paste, okay? So we'll go here. There we go. So it's this time now, we're gonna same basic approach, but I'm gonna use, instead of using the low-level JDK, new proxy instance, all that stuff, there's actually a higher level object that we can use in Spring. So the basic idea, here's the basic thing. So given a static void, execute with a method, okay, and given object args, okay. So I'm gonna extract out the important stuff in this proxy thing, okay. Object O, invoke. Oh, I want to have the. Did I not have? Throw an exception. Whatever. Who cares? What's the issue? Oh, cannot return the value. Okay, yeah, sure. So object. Okay, fine. So I've got that. So this code I could have rewritten as this, right? I could have said proxy method args, right? And that could have just been a method reference like that. Okay, pretty straightforward. So I've got the interfaces and I've got this call to this lambda. And that's pretty straightforward, but there's actually a higher level object in Spring that knows how to work with both interfaces for JDK proxies and concrete types, okay? So it's called the proxy factory. So I say new proxy factory. And the proxy factory, I'm gonna say pf.setTargetClass, right? And here I need the target and the target class, okay? Target class, and we'll call this target. Target class, pf.setInterfaces. Interfaces are target class.getInterfaces. Okay, and we want the set proxy target class. Yes, and what's going to happen if we set this type? If we have a concrete class without interfaces, it's going to use cglib-based proxies. It's basically going to dynamically generate a new class file at startup time that subclasses your class, adds your custom this execute method. It's going to execute around the execution of the method, and then it's going to call super. So it'll do the thing, call super, and then do the other thing around it, right?
But you said at startup time.
It's at startup time,
By
right?
default.
By default.
So we would need to make it also GraalVM friendly.
Exactly, and that's a big problem, is because it's going to try and create a new class and load it into the class loader at startup time, right? So this is, there's several things here that are just going against the grain of sort of upfront, closed world compilation, exactly. So we're going to say add advice, I guess, and we're going to create a new method interceptor. This is the AOP Alliance approach. And I'm going to say if null does not equal target, then pf.setTarget. So we're going to say the target is target, but only if the value for target is not null. That's this parameter here, okay? And then we return pf. So we say return pf, and this we can get rid of. So now I'm not returning the object itself. I'm returning the proxy factory that I can then use to get the object itself. And let's actually make this work too. So I've got this basic code. Execute, right? Execute against the target. And actually, let me just make sure. Var method name equals invocation.getMethod.getName. Voila. Okay, system out. And let's just take this bit right here. Print that out. So I've got invocation.getMethod, getName, okay. And then I've got the result, var result equals invocation.getMethod.invoke, passing in the target and the invocation.getArguments. And then I can print out this bit right here. Same as before. I should do try finally, but just for now we'll move a little quicker. Invocation.getMethod.getName, blah blah blah. Okay, and then we return the result. So I'm doing the same exact thing as before, except I'm doing it in this method interceptor. Same basic arrangement, right? And I've got this logging proxy. So this logic I can just get rid of. I've still got a bean post-processor, right? And now what I'm going to do is I'm going to have this test. I'm going to say if it matches this test, then I want to post-process it. So if it's that, I'll post-process it, customer service.class, okay? Same basic thing, but I'm also passing in this, and we'll talk about why in a second. Let's go ahead and, you want to try and compile this. Do .run. Okay. This is going to fail, sadly. And the reason, oh, yeah, didn't even get that far. The reason is non-sealed
interfaces.
Is that true? Oh, because I've got the JDK hints for the proxy, which is no longer appropriate, right? So okay, get rid of that. Goodbye. Okay, so this will take its time, but the reason this is going to fail is because, again, it's just doing all sorts of dynamic things. And again, if you're doing this kind of stuff, you're probably writing a library or framework that builds on top of Spring. It's very low level at this point, which is by design. Hopefully, most people aren't doing this. But if you do have to do this kind of stuff, then you're going to need this. And so I've actually spent a lot of time in the last several years working with different open source projects, helping them do this kind of stuff, right, with autoconfig and then with GraalVM support, with the AOT support as well. So it's very much I've got a library that I use that I build, that other people use, and they need this. Okay.
Okay, so it built.
Well.
But it failed when you're trying to run it.
Bean named customer service is expected to be of type. Oh, what did I do there? Oh, it failed for a different reason, which is I forgot to return. So I returned PF, which is a proxy factory. Oh yeah, okay, I forgot to call. Oh, so silly. I forgot to call that. Okay, it's gonna fail again. I failed to fail.
For a new different reason.
Yeah, I failed to fail. I can't believe it.
This new implementation, is this where we get to choose between JDK proxies and Spring proxies?
Yeah, so yeah, exactly. So this is gonna, you'll get it'll do the work for you. It'll figure out if you need a JDK or a Spring one, basically. But okay, I've got a new object of type customer service, right? That's what that is, ultimately. But it's still gonna fail. Faster, fail fast. Okay, good. Failed for all the right reasons, right? CGlib runtime enhancement not supported on native image. Make sure to include a pre-generated class on the class path instead. So it's thinking it's thinking this should have been loaded at compile time, but it's not. We generated it at startup time. So this can basically be made to work, but we have to use a slightly more specialized implementation of the Bean post processor called the Smart Instantiating Bean post processor, and it has a method called determine bean type. In that method, you have to basically predict what the bean type is going to be. So I'm going to just basically the same exact test. I'll say, okay, return bean class.equals customer service, then logging proxy. We don't have the target, right? Remember we checked for that being null, but we do have the bean class, okay? And then we get the proxy class given the current class loader. So get that. Otherwise, we just return bean class. Okay, is that right? Looks, yes. Good. So Spring will look at this and it'll use it to realize that even though we have a bean of type C customer service coming in, the return value is of different type and we need to register a hint for that, okay? It'll detect that it's a CGlib, Spring proxy, etc. It'll call this at the right time during compilation and just automatically provide the hint. Or at least that's what I'm hoping. Come on, Spring.
Okay, so this time it should work.
I mean, yeah.
Hopefully.
So the good news is even I don't write this code a lot, so I'm sort of
So this is if you want to write your own framework, right? This is the kind of
low-level
things
stuff
you need to know.
It gets a little bit more neat in a minute. Okay, it worked.
Amazing.
Okay, good. So now, last trick. Okay, we've got proxies, and we talked about the runtime hints registrar, and we've made very clear that there is a component model that exists at compile time, and we talked about how that component model actually does things for you that you can take that are optimizing your code. One of the things that we can do is render out that JSON config. And I've done all that here thus far in terms of types that we know about, because this is our program and we know what types we're going to be using. So we've done that sort of feline.class and customer service.class. We just did it with that. But if you're writing a framework, then you might want something more low level, like those Bean post processors and the Bean factory post processors. And to that end, there are framework analogs that get evaluated at compile time, right? One of them is the Bean factory initialization AOT processor. And that is kind of like the Bean factory post processor. So static class, that's the first time I've typed in transient in years. I never use that part of the language. I'm sure it's useful. I just don't. Okay, static class. So, brap. Okay, so implements. B factory. Whatever. Blah. Okay, Bean registration AOT processor. So it's, that is brap. Yeah, okay, brap. Okay. And we have this callback interface. Hello. Process ahead of time. And the job here, we're going to register this now, right? Static, like that, return, new. Good. And this callback interface, you get a thing called a registered bean, which is like a bean definition. You have the bean class, the bean name, the bean factory, the bean types, and the merged bean definition that you can then use to get the constructor, the dependencies, the fields, the constructor args, all that kind of stuff.
Can we modify bin definitions here in this processor?
Not really.
Okay,
maybe.
So we can look at them.
Yeah, well, you could. So you can register. The idea is that you can inspect them, and then render, for example, those hints. So remember earlier we did all this stuff up here with the runtime hints registrar.
Ourselves, yes.
Yeah. Well, let's say I had some generic thing, right? Some sort of framework-y type thing. Maybe I want to register for serialization, right? So where's our serialization thing? Here.
So you want to know that if some class, it will need serialization, right? You want to produce that serialization config here yourself.
Automatically,
yep.
Right? So we can say if serializable is assignable to var class equals registered bean.get bean class. So class. If serializable is assignable from class, then return a thing called bean registration AOT contribution. Okay, and here we get access to the context and the code. And with the context, we get the runtime hints, our old friend hints. Okay, and here we can say hints.serialization.register type, and the type is class. So now it's generic. Now I don't have any awareness particularly of this particular type called feline, but if it's a bean in the context, so where's my customer service? Maybe, actually no, here, let's create a shopping cart. So at component class shopping cart, it's going to be you can imagine this would be serialized. I could have like at scope session. I don't have the web framework on the class path, but if I did, I could use that. And then this would be serialized in the shopping cart in the HTTP session. But I want to make sure that kind of stuff just automatically works. So I've got this new, I'm going to do this bean registration AOT contribution that looks at the type, and it has to be serializable. So I'm going to say type reference of class.getName. Nope. Get name. There you go. Okay. So I'm programmatically registering a hint just for that. Okay. Whoops. There you go. Lambda. Okay. And so I guess we could write it out. So system out registering hint for class.getName. Good. So now let's restart this. Did I register it? I did. Brap. Okay. Go back here. Okay. This is going to render the. You can actually put this in auto configuration. You can put it on the class path in your library or something. You can register it. Actually, there's even AOT.factories. That's a text file that you can use instead of registering it in a bean definition as a bean method with static, blah blah blah. You can create your own file called source. What is it? Source. Where's my? Whatever. It's AOT.factories. It is usually. This is useless. Where's my? Just give me the value. Wait, can I extract this?
Okay, but look, our app built.
Yeah.
And it's all fine.
Meta-inf spring, right? Meta-inf spring, and then I think it's AOT.factories, and you say runtime hints registrar, or you can do one for the bean registration AOT processors. You can register them and package them and distribute them in your organization. Okay, so that worked, right? We were able to detect that it's serializable. Did it print out that it's registering it?
I mean, it compiled.
Very
good sign.
It registered the hint for the shopping cart and for the other things in the bean factory that were serializable. Okay, so great. So that worked. That was just very generic kind of code, but you can imagine doing something more sophisticated. Now, for our one more thing.
Oh my God! Like I would say, it already was like on a scale from 1 to crazy. That was already crazy, but we are ready to take it to the next level.
I'm
crazy.
Ready.
So stay with us. We have 15 minutes. We think we can do it.
I have. This is so. What if? So we're using Spring here to get a hold of the runtime hints. We're registering a type. What is that doing? It's actually generating it's adding entries to the Spring AOT resources, reflect config, serialization config, and so on. You can see that thanks to our little BRAP thing, bean registration AOT processor, that we have a shopping cart in the serialization config. So our Spring code is being executed at compile time, and it's writing out entries into the JSON config during compilation. But I wrote this code in the same place as my production code. It's right next to my Spring beans that will get run at production. So what this means is the AOT engine, the Spring plugin, is running the code. It's doing all the ingest. It's looking at all the XML, all the Java config, all the component scanning. It's taking all the inputs from all that, and it's creating a bunch of bean definitions during compilation. And then it's giving our callbacks, our AOT processors, our runtime hints registrars, our register for reflection binding. It's giving all these things a chance to run during compilation, but they don't get to execute against real objects yet. They never move past the stage of like having bean definitions. But all this happens at compile time. And we use this as a chance to inspect all the beans and all the bean definitions and set the stage for the application that will get fed into the GraalVM native image compiler. One other thing that we do is that we also rewrite your code. So we rewrite it so that when you run the program in compilation in native image, you're not running at component scan and you're not reading the XML. There's no XML parsing. There's no Java config. We're not looking at your classes and finding all the methods of type bean using reflection at startup time. All of that gets normalized away. We take all the bean definitions and we write out an optimized, reified version of all that for you into a Java class, and that's what we compile. And so if you go here, you can see sources, com, example, customer service bean definitions. Here's my shopping cart bean definitions. Here's the registrations. We're using, behind the scenes, we have used functional config. Remember I showed you the functional config with the application context initializer? We transformed your component scan, your at configuration, your XML, all that into functional config. So there's no need to do reflection, no need to read the XML and resource loading. We're not doing any of that stuff. And that means that the native image doesn't need to have any of that reflective metadata in the heap in order to do its work, because we're going straight to the bean definition representation of the object, and then that gets loaded into real objects, right? We're skipping all the metadata, all the reflection, all that kind of stuff, okay? So that's what's here. I've got this customer service bean definitions dot get customer service bean definition. This is a class that was generated by the AOT engine, right? And if you can see here, here's the programmatic, I'm building up the customer service bean definition, right? Setting the instance supplier, you just call the constructor. And then here's my application context initializer. Remember we looked at that to do the functional config for bar earlier on, right? So we're generating this is actually really efficient. That's why we're doing it like this.
I mean, it's efficient, but it kind of looks scary, right?
Yeah,
the good thing is not something you write yourself, but Spring will generate it for you, right?
Exactly. Well, the important thing here is that we're generating Java code. By looking at the bean graph, we're taking all those beans that in the bean definitions, and then we write out Java code to programmatically rebuild the exact same bean graph, but skip all the XML config, all the component scanning, all the Java reflection and bean definitions and add components and all that. We don't have that anymore. There is a SPI for code generation. And that's where we reveal that actually Spring Boot 3 is Spring Roo from 2009. I'm just kidding. No, it's actually it has a code generation SPI. That's the important thing. And you can use that. So let's just take 10 minutes to write one last thing here to generate a very simple example, okay? So let's say simple service.
So what we'll try to do there is we'll try to generate this code ourselves from our application and see if we can get that Java source code generated.
Yes, but I'm gonna just cheat a little bit here.
Let's cheat, because there is no way on earth we will implement this in 10 minutes.
No. It's gonna be, okay, going down here. Give myself plenty of room to stretch out.
That application is really blowing up.
Okay, so now I've got a simple service. It's gonna take a Java instant and a file, okay? And I'm going to compile. What I want to do is I want to have information. I want to be able to see when this program was compiled, and I want to see the file in which it was compiled, the directory. Okay. So I've got this new thing that I've written called the Simple Service AOT processor, and what that's going to do is it's going to implement bean registration AOT processor. Okay. And here.
So this is similar to what we did for serialization, right? We also had a processor there, and this one we will use to generate code.
Is it this one? Okay, yeah, there we go. So I'm gonna check and see if the class is assignable from the registered bean class of this one right here. So if simple service class is assignable, that's what I'm basically testing there. And so I'm gonna do that. That's the same pattern. I'm matching and then I'm applying. So then I say, okay, if it's not assignable, then return, because we don't want to do anything. We just want to return null. But if it is, then I'm going to return a bean registration AOT contribution, okay? And here, I'm going to get the current generated classes from the context. I'm going to generate a new class, okay? And I'm going to say, create a new class called, class simple service feature, okay? I'm going to create it manually using this. And I'm going to make the class public. And by the way, this API that we're using here, add modifiers and all this kind of stuff, all the add parameters, all that, that is Java Poet from Square. How many of you have ever used this, right? Square. That's this right here. This is a API that was it's a Java API for generating Java source code files. And it was created originally for use in Android, right? They have a nice dependency injection library that does JSR 330 support for Android called Dagger, right?
Oh, I see some Android people contributing to the...
Yeah.
Yep.
So this is lots of so it's a nice API for programmatically building Java source code. And we inline that now. So when you use this API, right, you're using org Spring Framework Java Poet. We're just vendoring it. It's just their code in the Spring Framework, sort of like CGlib and a bunch of other stuff, okay? Okay, so generated classes, get or add a new class. The generated method, we're going to say get the methods that are already being generated and call this new method devox for the win, okay? And then make and modify the method that we just created by adding the modifiers public and static. Add a parameter of type registered bean and another one of type input bean, which is the actual class itself. And then return the class, the instance of the class itself. That's the return value, and then add some code. We're going to say input bean dot provide origin, providing at compile time. This code is getting executed, okay? Providing the current time and the current file. So I've written Java code to instantiate an instant and a Java file, but I'm going to provide it values during compilation, okay? So the current time during compilation and the current working directory during compilation, and then we're going to add that method reference to the instance processor, okay, post processor. So let's register this thing here, and that is, BRAP2, I guess.
And the way this is possible now is because we have this compile time now, right? And we have this ahead of time processing, so we can do crazy things like that because we now have this AOT engine that will help us generate this code.
Exactly. So good. So there's this. So now go here. Hey, get back. Run. Okay, so
this will build our application as an executable, but also it will generate that class for us.
Mm-hmm. And we can actually already see it, I guess. Sources, simple service feature. There's this code.
Amazing.
So I have now if I inject this, if I were to inject an instance of this simple service and then query its state, then I would be able to see the time and the place it was built, right?
And this was generated from our application.
Yeah, exactly. We code generated new things and changed the beans at compile time, and that get reified for runtime. Why is this important? Well, if you have something you want to do dynamically, and you can figure out everything that's required to support that feature at compile time, then write the code to automatically reify that state. Skip the dynamic stuff at runtime. You don't have to, but if you don't want to, clearly it's possible to get around a lot of this stuff without doing something like this, but it could be very powerful. I think we did it. I can't believe it, but we did it.
We have 5 minutes, we can wrap it up.
Yeah.
Just go through the basics again.
Oh, I'm just going to throw this in the trash.
Do we want to show people how do we start with Spring and GraalVM and everything? I guess we can talk about it.
Yeah,
so we can get GraalVM from SDK man. Just do SDK, get Java, get GraalVM for JDK 21. That's how you do it. And then you go to start with Spring.io, Josh's happy place. You generate a new project, and you can get GraalVM for JDK 21, Spring, and all the latest features to work with your application. And I hope that most of the things that we showed together today, you will not need to use them. So hopefully what we showed before the break, where you just get your application, add dependencies, compile to native, everything just works. We hope that will be your pass for the 99.9 cases. But in case things don't work, frameworks like Spring give you a way to easily register reflection, etc., from your application.
So, who had fun? Who learned something new? Okay, good. There's never been a better time to be a JVM developer, my friends. It's just never been. Go out and try it. Java 21, GraalVM. It's just free money. Like, go. It's just really good. It's a great time. Great time. Go try it out. Thank you, Alina. It was great.
Thank you, Josh. Thank you all for coming here.
Thank you, everybody. Please vote.
Yeah, please write this session.
I want them to invite us back, and
next year.
Yeah, next year, or indeed any year. Really, I'm just happy to be here. Bye. Oh, also, we're doing sessions. Come to our sessions. When's yours?
Mine is tomorrow with Fabio. We have another GraalVM deep dive. Yay. And you are on Wednesday?
I've got a talk. There's a Spring Buff tomorrow night, and I've got a talk on Wednesday called Bootiful Spring Boot 3, which will be a lot more rip-roaring and,
So see you tomorrow and see you on Wednesday.
Yep. Bye.